All right, we're recording. Hello, everyone. Welcome to the day 3 of our Forge online training webinars. Um, in case any of you are here with us for the first time today, just a quick recap what this event is about. This is a series of webinars where we basically guide you through developing some kind of Forge application by following one of our tutorials online. So we, as the Forge Developer Advocate team, we provide all sorts of learning resources for you to get started with Forge or even to dig deeper into the more advanced topics. One of those popular resources is a website called Learn Forge or learnforge.autodesk.io. Um, we believe those tutorials on that website are pretty self-contained and self-explanatory, but at the same time, we do acknowledge that some of our customers prefer a more guided approach where we can actually take you through the tutorial and explain what to do and what to be careful about. That's why we do this type of event where we actually guide you through a specific tutorial step by step, always giving you some time to follow these steps yourself and then later regroup and answer your questions if you have any. Um, it's a 4-day event this time. We're at day 3. Typically, there are 2 parallel tracks for Node.js and .NET. Today is a bit special because today we're actually going to move to the client-side development. So it doesn't really matter what language you use on the server side. So we're going to have a bigger group today, hopefully. And each day is split into 4 sessions where we always show you a little bit of the tutorial or some of the preparations, how to do things, how to implement some piece of functionality. And then we give you some time to implement that piece yourself. During the session, we show you the code, we do a live coding demo, we answer your questions maybe from an earlier session, and then between sessions, it's your turn to follow the same steps and make that additional step in building the application from the tutorial yourself. As for today, we will be showing you how to extend the viewer component that you may already be using in your Forge application, the Forge viewer library, and how you can actually start using the viewer to access and process some of the metadata from your models and use it, for example, to build all kinds of dashboards. And today, I'm also joined by my colleague, Deepali. Thank you, Deepali, one more time for joining us. Deepali is a great help addition to our team, and both of us will be guiding you through this viewer extension tutorial and answering your questions as we progress throughout the day. All right, so this is day 3. Thank you, Deepali. And this is what we're going to be building, right? So there's going to be a couple of things. Again, we're going to show you how to start extending or customizing Forge Viewer because the viewer is heavily customizable. We're going to show you how to do that in a clean way, how to add some additional buttons in the toolbar, how to trigger some custom functionality, how to extract information from your models using the viewer JavaScript APIs, how to add additional UI components to the viewer, as well as, again, for example, extend your overall application experience with dashboards showing all kinds of data computed from your design's metadata, for example. That is our goal for today. As part of the first session, we will do the usual intro and setup to make sure that we're all level set. And then when we move to make sure that when we move to session 2, that we all have a good starting point, right? That we're as consistent as possible when moving forward. And session 2, we're going to start by building a first viewer extension. And I'm going to explain what that is later on. And we're going to start looking at, working with some of the state management in the viewer. For example, how to retrieve information about what is selected in the viewer, right? How to control what gets selected or hidden or shown. In session 3, we're going to look at the UI customization, right? So we're going to look at adding some additional panels in the viewer that show our custom information. And we're going to start preparing some data for the final session, session 4, where we're going to add the third, an open source library called chart.js to actually start visualizing this data extracted from our designs using the viewer APIs in form of, let's say, a bar chart or a pie chart. Okay, time for session 1, or maybe let's check the chat or Q&A if there are any questions. Yes, Deepali, thank you very much. There was a question about the recordings of these webinars. Yes, all these sessions are recorded and we will share them with all of you after the event, with everyone who registered through Eventbrite. All right, prerequisites. Once again, what we would ask you to have ready when we move to session 2 is a Forge account and Forge application. And again, real quick, if this is your first time with us today, what you'll need when building your Forge application is, first of all, a Forge account. If you don't have one, you can simply head over to forge.autodesk.com, and on the front page, hit the sign up to try Forge. This will get you an account in Forge with a trial subscription that'll give you some amount of cloud credits that you can start using when working with Forge. And then once you have your Forge account, also make sure that you have a Forge application record. And what that is, well, let me sign in first here so that I can show you. All right. There we go. So a Forge application is basically, very simply put, a username and password that your code, your application will use when communicating with Forge, right? So you will actually need to prove that you are who you claim to be when communicating with the Forge services. And for that, we use something called a Forge application. I already have plenty of these here because, again, I typically create a separate application when working on a prototype or demo for a customer. So that these apps are nicely siloed, right? And one customer cannot see the data of other customers. If you don't have an application yet, let me show you how you can create one. Just hit the Create App button, and you'll be presented with this interface. First of all, you'll want to choose the APIs, the services from the Autodesk Forge platform that you're planning on using. I would suggest for now to just check everything, even if you're not planning on using something like TokenFlex for now. Because I don't believe there's any downside in enabling everything. Then provide some name for your application. So I'm just going to say, in my case, maybe Forge Online Training, April 2021, day 3. That's going to be extending the viewer. All right. And as for the final 2 fields here, the callback URL and the website URL, it doesn't really matter what you put in the website URL. It can be any bogus name. Here, the callback URL will be important if you're planning on reusing your application that is using 3-legged token authentication. So this is something that was explained during day 2 when we talked about building applications that are able to access your users' data in other Forge products, such as BIM 360 or Autodesk Construction Cloud or Fusion Team, for example. So this field will only be important if you're planning on using that application, maybe reuse that app. For now, we will not go into too much detail here on this topic. So for now, I'm just going to say localhost, maybe callback. You can enter a bogus URL there. You can always come back to your app in the Forge portal and change it later. What is important after you create the app are these 2 values, the client ID and client secret. These are your application's username and password, sort of. Those are the 2 values that you're going to be using when authenticating yourself to the Forge platform and to the different Forge services. So keep note of these 2 values, or just leave this page open for later when we get to that point, because again, you will need the client ID and client secret when setting up your web application if you don't have one already. All right, let's go back to our slides. Now, for the development setup, again, as I mentioned earlier today, it doesn't really matter what kind of environment you're using, because now we're going to be working on the client side, on the job, extending the viewer and adding some charts into HTML markup. So what we recommend you do, because we believe that most of you joining us today have already gone through the day one or the day two tutorials. So we expect that most of you will already have an existing app from those previous days. We definitely recommend that you reuse that one, right? But again, if you're new here, if this is your first day with us during the edition 2019, and that if you don't have it installed yet, make sure that you have ASP.NET web development and .NET desktop development workloads installed with your Visual Studio app. If you prefer a Node.js, oh, I probably hit it here. If you prefer Node.js for your development, we recommend that you use Visual Studio Code. And we just ask you to make sure that you have the Node.js binaries available on your system and that you can run them from command line, whether it's a terminal or command prompt, right? We just ask you to make sure that you have access to the Node and npm command. That's the Node package manager. And I'll show that momentarily. In my case, I'm going to be reusing the application we built during day one. And I'm going to be using Node.js in my case. But again, you're free to reuse any other kind of application, any other Forge application you may have already built, even maybe in a completely different language. If you already have an existing Forge app that is using Forge Viewer on your page, that's perfectly fine. You can use that app, and we will start experimenting with the viewer APIs, and we will start extending the front end, right? The UI and the viewer itself. Now, if you don't have a starting point, if you don't have any existing application to start with, when we move to session 2, there is an option for you as well. If you head over to the tutorial website that I mentioned earlier, the learnforge.autodesk.io, you will notice that, where are they? Here. You'll notice that for some of the basic tutorials, like the View Your Models, that's the one we covered during day one, or the View BIM 360 and Fusion Models, that's the tutorial we covered during day 2. For each of these, you actually have access to full implementation of that sample app already, right? So when I go to View Your Models on the LearnForge website, you'll see at the bottom of the page that if you want to download the project ready to use, here are the GitHub repos, right? What I can do is, for example, if I don't have any existing Forge application to go with, I can just choose maybe Node.js or .NET Framework, or maybe even the full implementations for some of the other programming languages. So I'm going to go with Node.js, and it'll take me to this Git repository that, again, includes the complete implementation of what we built during day one. And what you can do here is you can either clone this repo and check out this Node.js branch, or what might be easier for you, for those of you who, again, don't have any app to start with, is just downloading the source code in a zip file. And when you extract it, you'll basically have your complete source code available, right? So that's another way to get some kind of application to start with. Of course, you'll still need to set up your app with, again, the credentials with the Forge Clan ID and the Forge Clan secret. All of that information you'll find in the README, right? So you will know that, for example, after you've downloaded the zip file and extracted it, you will need to set the 2 environment variables when running our Node.js project in this case, to make sure that our server application can get this username and password sort of when communicating with Forge and to authenticate ourselves to Forge. So on Unix-like systems, in a standard terminal, you can do that using this export. You can say export Forge client ID equals, and then you use your client ID, and same for the secrets. Or if you're using Visual Studio Code, you can create a launch configuration. That is maybe a more convenient way, because that way you can also launch and debug your application from within Visual Studio Code. But again, that's more specific to those of you who maybe are using Node.js and Visual Studio Code for your server-side development. And similarly for .NET Framework, right? If you prefer to get a new application, Forge app to start with, and you prefer .NET Framework, similarly, you can just head over to the net branch of the LearnForge View Models GitHub repository. And you can again download the zip file and get access to the complete source code. And again, follow the README to make sure that you actually, in this case, in case of .NET Framework, that you pass in the configuration options, your Forge application client ID and client secret, into the web config file. All right. Oh, here it is. So this is when you're using Node.js. Just make sure that you have a command line environment like terminal or command prompt, or maybe if you have installed Git on your Windows system, it should come with something called Git Bash, which is a terminal bash environment available on Windows. So I would recommend using that as well. Let me just quickly show, since again, in my case, I said I'm going to be using Node.js. If you want to use Node.js as well, make sure that in your command prompt or terminal, you have access to two commands. Node, that's the command that can actually execute JavaScript code as a desktop or server application, and npm, the Node Package Manager. That's what we're going to use to, that's what we typically use to bootstrap new Node.js applications, to install or upgrade dependencies and things like that. All right, so as I mentioned earlier, in my case, I'm going to be using the application we built during day one. So let me just go back to the source code, view models. All right, this is my app. And in my case, I'm going to be using Visual Studio Code. Right, so I'm just going to make sure, well, first of all right, I'm just going to make sure that my Forge client ID and the Forge client secret are up to date. In my case, since I'm using VS Code, I've created a launch configuration where I'm already specifying Forge client ID and client secret. Let me just double check if these values correspond to the app I created. Actually, maybe I'm going to use a new one. I'm going to use the new app that I created today. So I'm going to copy the client ID and update it here. I'm going to copy the client secret. Be careful, you don't want to share your client secrets anywhere. Here I have to expose the client secret because I'm sharing the screen with you to show you how it's done. But what I'm going to do is after the webinar, I'm going to go back to this page of my Forge application. I'm going to use this regenerate button to basically have Forge create a new password for my app, so the old one will no longer be valid. All right, so that's my app. Now if I try and run it, and I head over to localhost 3000, I should see my basic app. I can just create a testing bucket and maybe upload a file. If I right-click test bucket and upload a file, Let's try maybe, which one? One of the official Revit samples. All right, so it should be uploading now and translating. Let's see. Listing the contents of our buckets. No, hasn't uploaded yet. Right, let's try one more time. Uploading RAC basic sample project. Or maybe I broke something when I was playing with my app. Let's quickly double check. Say uploading here. Upload file. Oh, there we go. So now it's pending. So we're uploading our Revit model to our application and waiting for the response. While we're waiting, let me check the chats. Okay, thank you, Deepali. All right, so the upload was successful. Now, if we refresh our buckets, we should see our file there. And if we try and open it, we won't see anything just yet. That's because in this application, we're actually not translating the file for viewing automatically. We're leaving it as an on-demand. So when the user actually requests that file to be translated, only then we trigger that operation. So here we do that through the UI where we ask the user to start translation. When that happens, we send a request to our server application. And that server application then sends a request to Forge saying, okay, please take this Revit file that the user uploaded and start extracting information from it for viewing and other processing in the future, right? So we have now triggered some conversion operation running in Forge, specifically in the model derivative service. And we can try view that model by clicking on it again. So we see, okay, the translation is still in progress. So we will try later. All right. Again, I see there is a question in Q&A. And somebody says, when I added the delete button, the upload button did not work. I see. Okay, so this might be a remnant of our hacking from day one, where we tried adding an additional button to the context menu for buckets, where we wanted to add an option to delete bucket as well. And it looks like we may have broken something while doing that. But now I was able to trigger the objects upload. All right, let's try again. All right, it's taking some time. All right, so while we're waiting for that, let's move on. This was for our demo time. And so now it's going to be your turn. So again, when we meet for session 2, make sure that you have a Forge account and Forge application ready, and basically that you have some kind of Forge app running on your machine, right? Either reuse the one you built during day 1 or during day 2, or head over to the LearnForge website to learnforge.autodesk.io and get one of the basic tutorials and download the zip file with the source code of that complete application with the programming language that you prefer, and follow the README steps there to make sure that you pass in the Forge client ID and client secret variables as needed. All right, let's take one more look at our application. 71%. All right, we're getting there. So let's check the Q&A one more time. All right, there's a question. Instead of using new buckets and you use AWS or Google Drive, are there any resources for that? So you're with Forge, you're free to use any storage you want. The only thing that is required is if you want to process your files with something like, let's say, Forge model derivative service, for example, converting them into the format that can be viewed in Forge Viewer. For that short amount of time, the files need to be present in Forge in one of the buckets, right? But they don't have to stay there. You can actually mark your bucket when you're creating it as a temporary bucket, which means that, or transient even, which means that the data in that bucket will automatically be removed after 1 day or 30 days, right? So some of our customers do that as well, right? They use the buckets in the Forge data management service only as a temporary storage. And they use Dropbox or Google Drive to actually, because they've already been using it for a long time and they have all their documents there, right? Their systems built on top of Dropbox, for example. So you're definitely free to do that. All right. Can we use day 2 application? Definitely, yes. Any kind of, even another Forge app that you've built yourself that has nothing to do with the tutorials that we've covered during this training, right? If you have an existing Forge app with Forge Viewer being used on the page, feel free to use that as well, right? That will work fine. The only thing you may need to do a bit more work when actually adding some real estate for the charts that we're going to be adding, right? You may have noticed in one of the animations that what we're going to do is we're going to update the layout a little bit so that when you click on something, that when the model loads, we will actually squeeze the Forge Viewer, right? Make it narrower, and we're going to add some extra HTML real estate on the right to add our chart. So that would be the only thing that would be a little bit more work for you if you want to use your custom Forge app, but you're free to use any kind of Forge application, definitely as well. All right, another question. I have the day 1 application up and running. Day 2, you showed us how to register the app. I did not see how you did that, which is why it failed for me. Registration, I believe by that you mean the provisioning, right? So just a quick recap for those of you who maybe have some pending questions about the provisioning term that was used during day 2. What that means is, if you want to build an application with some login workflow where your users will be able to log in and then see their content from other applications like BIM 360, for BIM 360 specifically, there is an additional layer of security where BIM 360 requires you as a developer of that Forge application to whitelist your Forge app inside BIM 360. In other words, BIM 360 will not just automatically allow your app, your Forge app, to access your users' data in BIM 360. If you want to do that, you will need to add your application's client ID to a list of allowed apps, basically, in an admin interface of BIM 360. That's called provisioning. And to learn more about that, just head over to the documentation section of the Forge developer portal, the forge.autos.com, and head over to, in the documentation section, look at the developer's guide of BIM 360. Right? Again, here, BIM 360 is a service part of Forge that allows you to access your BIM 360 data. And here in step-by-step, getting started, here's where you will find all the information. So first of all, how to get started with BIM 360, how to get a BIM 360 account, and more importantly, how to switch your BIM 360 account to developer account. This is what you'll need to do. Send an email to this email address asking to have your BIM 360 project or account switch to developer mode, because at that point, and only at that point, when it's switched to the developer mode, you will see in the admin interface under settings, this link, custom integrations. This is basically the whitelist that I was talking about, right? If you want to make sure that your Forge app can access your user's data in BIM 360, your Forge app and its client ID will need to be added to this list. So what you want to do is hit this Add Custom Integration button and paste your client ID of your Forge app and the name of your Forge app to these fields, right? When you do that, at that point, your app will be allowed to access the data in that specific BIM 360 account. All right. Another question, do you think that in our dashboard later we can add a scroll box to change the properties that we want to see in graphs through the UI? Yeah, so how about this? We're going to follow the tutorial as explained on the Learn Forge website. And then if there's some time left, we can definitely, talk about different ways to customize or extend that user experience. So yeah, we can take a look at maybe adding a Dropbox, or sorry, a drop-down select HTML button to maybe selecting the properties that we want to use. Yeah, that's a good idea. I like that. So let's see if there's time for that when we're done with implementing the dashboard UI. All right. If we have questions after this session or entire course, how do we get them answered? All right, so I do have a slide at the end of my deck that I'm going to share with you at the end of session 4, where we explain all the different ways you can get support from us. But I can tell you right now, we typically recommend these main 2 support channels. Either if you have a technical question that can be public, that is maybe more general, right, about some of the specific pieces of the Autodesk Forge platform, we recommend that you head over to Stack Overflow and either look for existing questions about that in there, or maybe post a new question about your problem or inquiry. When you do that, we get a notification in our system, and one of our colleagues will get back to you and answer on Stack Overflow. If the question you have is more private, maybe you need to share some proprietary designs that you don't want to share with anybody else, we recommend that you send us an email to the official email address forge.help@autodesk.com. Let me type it in the chat. forge.help@autodesk.com to everyone. All right. When you send an email to this address, we will receive a notification in the same system, right? So again, me or one of my colleagues who are available will get back to you there. All right, and another question. I've had some connection problems during the first minutes of the session, apart from the first and second day's code and Forge app. Any other action needed for today? No problem. No other action needed. Basically, before we move to session 2, just make sure that you have some kind of Forge application with a viewer ready. Ideally, reusing one of the apps we built during day 1 or day 2. If you can get one of those apps up and running, that's all you need for the other sessions today. All right. Great. So then, looks like there are no other questions. In that case, good luck, and we will see you in roughly 1.5 hours to move on to session 2. All right, have fun. Okay, we are recording. Hello, everyone. Welcome back to session 2 of our webinar today, where we talk about extending the Forge viewer in your application and extracting information from your models to build different kinds of dashboards. Now we're moving to session 2, and now we give a little bit of time to see if there are any other questions, any problems you may have run into while preparing for this session. We've answered all of the questions that were posted through Q&A. But again, if there's anything else you want to maybe clarify, let us know. Now's the time. Otherwise, we can move on to the step 2. All right. In that case, let's take a look at what we're going to be building in this segment. We're going to start by building something called viewer extension. So I promised earlier that I would tell you a bit more about what that means when we get to this point. The viewer, the Forge viewer library, the component that you're using in your Forge applications in your web page, is heavily customizable. It provides a rich set of APIs, JavaScript classes and methods that you can use to get information from the viewer about your models or about the state of the viewer, as well as controlling the model or the state of the viewer. We can take a quick look as an example. If I run my application that I had prepared earlier, that's the simple Forge app we built during day 1. If I just head over to localhost to see my app in action, here's a cool little trick that some of you may already know, but some of you maybe not. And I think this is really important and really exciting to know. Since Forge Viewer is a piece of JavaScript running inside your browser, you can interact with it as with any JavaScript code that might be running on your web page. In case of our viewer, if I open the DevTools in here, in this case I'm using Chrome, but all the other modern browsers will give you a similar functionality where you can get access to a console where you can do stuff, execute JavaScript statements against your page, or look at some of the JavaScript variables or objects that might have been defined by different scripts running on your page. And here's a cool trick. When Forge Viewer is initialized, it actually stores its reference to the main viewer object to a global variable called NOP_viewer. It's all uppercase. So if I search for NOP_viewer, you'll see that this is actually a reference to an instance of our viewer. So we can already start experimenting with Forge Viewer and with the viewer APIs here without having to go back to our editor, change some code, reload the application, and reload the browser. We can actually interact with the viewer right here during runtime, which I think is pretty amazing side effect of this web development world. So let's try that out. Let's say I'm gonna select a couple of things in the viewer, right? A couple of elements of my design. What I can do is, using the NOP viewer, if I type NOP viewer dot, I will even get IntelliSense showing me all the properties and methods available on the viewer. And I can type something like get selection. I know that it's a method. If I call it, it'll give me a list of 2 numbers, right? Those are the Forge IDs of these elements that I just selected in the scene. I can go the other way around as well. I can say NOP viewer select, and I can pass in an array of numbers. Those are going to be the Forge IDs of the objects that I want selected. So I can say select an object 2226. Boom, that's it, right? I can also say NOP viewer fit to view, which basically means move the camera to a position so that certain object or certain collection of objects fit to the entire screen, right? So if I type this, fit to view 2226, I'm basically saying, hey, Forge Viewer, focus your camera on that one object with the ID 2226. And that's exactly what happens. Again, similarly, as I mentioned earlier and during the previous days, you might remember that the Forge Model Derivative Service, one of the services in that portfolio of our platform, is responsible for extracting all sorts of information from your designs. And for different types of designs, it will be able to extract more or less information, right? But for example, in case of Revit, it will be able to extract the the structure of Revit families and Revit family instances, and it will be able to extract the property metadata for every single element in your design. And this information you can either access directly through the model derivative service, or you can access it through the viewer APIs, because the viewer actually, when it's opening your model, it's not only downloading the 2D drawing or the 3D model, it's actually getting all the hierarchy and the metadata as well. You can see it here when I close the DevTools and I select, let's say, the roof. I can open this model browser here, and you can see that this extra information was also, that's the, the family, the Revit families and their instances. All of that information was extracted by the Forge model derivative service and stored in a special file. And the viewer, it's downloading this file as well to be able to present you with this hierarchy and to allow you to, select things and navigate to different elements in the tree that you click on. Show all objects. Similarly with the metadata, there's another button in the toolbar called properties. And this shows you the properties of different objects you've selected. Again, all this metadata you can either access programmatically by making a web request to the model derivative service, or you can actually query the same data through the viewer JavaScript APIs. That's what the viewer here is doing itself, right? We can do that too, programmatically. So let's try something else. Going back to the DevTools, to our console, I will try and say nopviewer.getProperties. That's another method that accepts a number. That's, again, the ID of one of our objects that we're interested in. So let's try the, what was it, 2229, right? And then it expects two more parameters, a function that should be called if and when the properties are retrieved successfully, or a function that should be called if there was a problem. What I typically do when just playing with the viewer during runtime, you can just pass in console.log and console.error. Right? Those are just two built-in methods of that console object that is available on every in every JavaScript context in a browser. And so what we're basically saying is, hey viewer, retrieve all the properties for the object 2229, and if you're successful, just print them to the console using the console.log method. And if something goes wrong, just output the error to the console using the console.error method. We do that, boom, that's it. So you see now this async method printed the results into the console. So we've called it console.log. And here you can see some kind of information, or maybe it was 2226. Maybe I chose a wrong ID. Yeah, selection. Oh, it was 2226. So let me try again. 2226. All right, there we go. We should see more properties now. Ah, that's much better. See, so all the properties that Forge was able to extract from this specific Revit model, we can also access through JavaScript here on our webpage using the viewer APIs, right? That's what we're going to be using in this session and the upcoming sessions today. So again, the viewer is nicely, heavily customizable, right? It allows you to do a lot of stuff. If you're interested, if you want to learn more, head over to the Forge portal, to forge.autodesk.com, and to the documentation for the viewer. So just like any other web service or REST API that is part of Forge, we also have a section for the viewer itself, right? So that's the one outlier, which is not a web service, but a JavaScript library with its own set of JavaScript APIs. You can see them all here. So these are all the different namespaces that are available to you on the web page, and on that JavaScript code running on your web page that you can use and leverage. And the important one under viewing namespace is this class called Viewer 3D. That's really the instance that we're working with that NOP viewer variable, right? So all the different most of the really critical, important methods that are used most of the time, you will find on this viewer 3D class. So just like earlier, we were trying to call get selection, for example, right? So as you can see here, that's a method with no parameters that returns an array of numbers, which are the IDs of our models. And similarly, we were calling fit to view, or what was it, get properties, right? So there are plenty of different methods you can play with that the viewer APIs expose that allow you to, again, get information from the viewer or from the model, or actually even control the state of the viewer, the camera, the colors of things inside the model, and things like that. We'll be looking at that today. Now, going back to our presentation, it's okay to just, start throwing JavaScript code into your HTML to interact with the viewer and to manipulate stuff to, read information from the viewer. You can definitely do that. But it's better, we recommend that you implement this logic in something called a viewer extension. A viewer extension is basically a JavaScript class that extends the functionality of the viewer in a reusable way, meaning that if you write your custom logic for the viewer in form of a viewer extension, it will then make it easier for you to reuse this functionality and maybe share it with others or reuse it in other applications, right? In that case, there'll be this nice separation between the application behavior itself and a viewer extension that, again, adds some functionality to the viewer itself, but does not depend on any app-specific logic, right? Then you can, again, share this code with others. We even have a page, maybe if you're new here, that web page is called forge-extensions.autodesk.io. And on this page, we show what, again, it looks very similar to the apps we built, right, during day 1 and 2. This application allows you to just select one of the pre-uploaded sample models, and it allows you to explore the viewer extensions that are available. One thing I forgot to mention, right? Oftentimes you see things like this explode tool or section or measure tool. Those are actually viewer extensions as well. These are enabled by default, so they always appear in the toolbar. But then the viewer comes with a couple more built-in extensions as well that are not enabled by default. One of them is, for example, an extension called visual clusters. If I enable it, you'll see that it actually adds one more button to the toolbar. It extends the functionality of the viewer, right, with one more feature called visual clusters. And when I hit that button, in this case, what this extension that's built in the viewer, what it's doing is it will regroup all the different objects. This is specific for Revit based on their family type. Right, so if you want to be able to quickly visually find something, let's say maybe one of my stairs, instead of looking through the 3D model or through the model browser, I can actually use this little nifty extension, viewer extension, to regroup all objects based on their type, find the the stairs I want, maybe select them here, and then hit the button again to move everything in its original place. And you see my stairs are still selected, right? So that's like this little idea of, again, yet another functionality that is actually already hidden inside a viewer, just waiting for you to enable it. And we also provide some custom viewer extensions. And again, since we are implementing them as viewer extensions, it's very easy for you to reuse these, right? These are just under the hood, just simple JavaScript classes that you can add to your application and add the name of the extension to the viewer, saying, hey, viewer, please bring this extension in as well. And that's all you need to do on the integration side when somebody shares an extension with you. All right, so what we're going to do is we're going to start with a simple viewer extension skeleton. Like we're going to write a simple JavaScript class that defines a viewer extension, and we'll show you what needs to be done for that, right? So we're going to prepare a JavaScript file, also add a little bit of CSS so that we can add a new button into the toolbar, and we're going to add both of these, the JavaScript code with the class and the CSS to our application's HTML markup. And finally, the last step that needs to be done, we need to tell the viewer that we actually want to load this new extension that we have just created. And then we're going to move on to another part of the extensions where we're going to start looking at, okay, how we can actually do stuff inside the extension, right? How we can actually start leveraging the viewer API. So what we're going to do is we're going to take a look at, getting information about what objects are selected, just like we did in the DevTools in the browser. We're going to, check properties of the selected objects, and based on some condition that we can, just think of, we will decide to either show or hide different objects, the subsets of those selected objects. That's what we're going to cover as part of this session number 2. All right, now it's time for a demo. All right, let me stop the app and head over to LearnForge tutorials. Again, this is the LearnForge website, learnforge.autodesk.io. And we're now moving on to this tutorial called Viewer Extension and the basic skeleton of the extension. Now, very simply, an extension class should just be derived from a class called Autodesk.viewing.extension, and it should at least provide 2 methods, load and unload, that should return true when successful to indicate that the loading or unloading of the extension was successful. These methods will be called by the viewer when the extension is loaded or unloaded. So you can use it to initialize different things, or maybe destroy some data in memory when the extension is unloaded and the data is not needed anymore. There's also a couple more methods that are not required but optional that allow you to hook into the different lifecycle events of the extension. One of them is called, on toolbar created. If you implement this method on your class for the extension, this method will be called automatically when it's loaded and when the toolbar is initialized, the viewer toolbar, right? So you can use this point in time in the initialization process to find the right time that, okay, now I can actually, as an extension, can start adding custom buttons to the toolbar, for example, right? Because by the time you call load, the toolbar may not be available yet, right? So trying to add something into the toolbar during the load phase might be a bit too early. So on toolbar created is definitely a better method to use to actually extend the toolbar UI. And finally, as part of this JavaScript code that we're going to add to our application, existing Forge application, is this last call to something called Autodesk.viewing.the-extension-manager. That's a global object that is used to basically manage references to all the different extensions that our viewer may want to use. So what we do with this line, we're just going to say, hey, manager, there's a new type of extension that we want to add to the global list. It's going to be called, let's say in this case, my awesome extension. And here's the class that implements the extension, right? That's the name of the class that we've defined here at the top. All right, so let's do that. Let's take this code and paste it into a new file we're going to create anywhere where we have our public client-side assets in our source code, right? And we're going to call it, in this case, myawesomeextension.js. So let me head back to my app. And in this case, again, since I'm using the Node.js app from day 1, in that application, we were storing all our client-side assets in the public folder, right? So I'm just going to go into the JS subfolder. I'm going to create a new file called myawesomeextension.js. Right. So we're defining our first extension class derived from Autodesk.viewing.extension class. During the load and unload, we just log something to the console, right? And when the toolbar is created here, we're already starting to get into the viewer APIs. We are accessing the viewer API through this.viewer, right? This will be set for us automatically. That's the same object we were playing with in the DevTools when we said NOP_viewer, right? That's the instance of the viewer 3D class, the main entry point for all the APIs. So we're just going to say .toolbar, meaning, get access to the toolbar of the viewer, and then .get control. So with this method, and again, you'll find the documentation for all of these on the dev portal. Now we're basically trying to see, is there any control in the toolbar called all my awesome extensions toolbar? And if not, we're going to create a new one, right? So we're basically creating a new control group that's basically a separate part of the toolbar, right? That's going to appear next to the icons that are already there as a separate group. So we're going to create that group called all my awesome extensions toolbar, and we will add that group to the toolbar by calling it add control method. And similarly, we then create a new Autodesk Viewing UI button class, and we add it to the group, right? And we also customize the UI of the button itself. We say that it's going to be called My Awesome Extension, and we're going to add a CSS class to it so that we can later style it. We can give it some color or image or whatever have you. And the important part here is we're also defining this on-click method on the button object, and this is going to be where things will happen when somebody clicks on that button. That's where we can actually incorporate the logic of our extension so that it can do something. It can compute some information, it can show something, it can change something in the scene, whatever you want to happen, right? So for now, I'm just going to say hello. I'm going to trigger an alert. All right. So that's one step, right? One of the 4 steps. So defining our class. Second is defining some styling again, in case you want to add a button to the toolbar, maybe you want to add some picture there, right? To that button. So what we're going to do is we go back to the LearnForge website, and you'll see here that we have a snippet here that you can use as a template, right? So we added a CSS class to our button called My Awesome Extension Icon. And now you can take this snippet of CSS and add it somewhere to your CSS in your app, right? So let's say in my case, I can just add it maybe to main CSS, or I could create another CSS file and include it in the HTML. It's up to you. Here, I'm just going to use one of the existing CSS files that I'm already including in my app. I'm going to add this class at the end. This isn't the indentation isn't looking right. Okay, so we're saying a button with this class, CSS class, is going to be 24 pixels wide and high, and it'll have a background image centered of something, right? So now this PNG, I don't have it in my source code. So what I'm going to do is I'm just going to go online. Sometimes I'm using this icons 8 library. So I'm just going to look for an icon, maybe something for like summary. Yeah, maybe this one. And I'm going to say embed HTML. I'm going to get the list PNG file. You can use any image you want, right? Again, maybe you already have some images in your source code. I don't, so I'm just going to borrow this one from the Icons 8 website. And to be a good citizen, I'm also going to take this credit link and add it somewhere to our application so that we get credit to we give credits to the author. Icons by Icons 8. All right, so this is how we style the button that our extension will add to the toolbar, right? And finally, well, the third part is we need to include this JavaScript and potentially the new CSS file into our app, right? Because the JavaScript, the My Awesome Extension JavaScript file will not be loaded automatically. We need to make sure that that file is actually brought to our web page as well. So I'm going to head over to the index.html. I'm going to add one more script tag to the head tag, pointing to the My Awesome Extension JS, right? And again, it's coming from the JS subfolder. And this, again, will depend on your application itself, right? If you have your own way of storing client-side JavaScript and loading them into your app, feel free to use that. Just make sure that this JavaScript code with the extension class is brought to the browser. And actually, I just realized something. We will want to make sure that this file is actually loaded before the viewer. This is also sometimes, important to think about the timing, right? Because somewhere in our Forge viewer code, we will later try and load the extension. So it's better if that extension itself is actually brought to the browser before we try and make that call, right? So just to be safe, it's better to bring the extension code to your app before you actually try and load the extension in the viewer. And at the same time, it should also not be too early, because if as you have seen, we depend on certain JavaScript objects to already be available in that browser page, right? We're assuming that by the time we define our class, there's already some object in the global scope under autodesk.viewing.extension, which is a class that we extend from. That class is going to be defined by this script, right? So what you'll need to make sure is that this script tag, where we're bringing in the viewer JavaScript code itself, is before we try and load in our extension. So that's for the order of things. All right, we don't need to bring in any other custom CSS, because for now I just added the CSS class into my main CSS file. I could as well just add a style tag here to make it even simpler, but then again, the extension style could not be reused easily, right? So again, always think about, is this something that's only specific for my own app here, or am I planning on reusing my JavaScript code or extension code or styles in other viewer applications potentially? All right, that was step 3. And finally, when we do this, the extension will be downloaded to the browser, it will be parsed, but it will not actually be loaded by the viewer. To do that, what you'll want to do is locate the line in your client-side JavaScript code where you're instantiating the viewer or viewer 3D or GUI viewer 3D class. In our case, that would be in the Forge viewer JavaScript file. And you will want to pass in the second parameter to the constructor. That's going to be the config options for the viewer. And one of the options is the list of extensions. So to make this more readable, let me do this. I'm going to define a new constant called config. That's going to be an object with different properties. Later on, you will learn that there are actually other properties you can set when instantiating the viewer, but for now, we're just going to use this extensions property, which is just a list of strings representing the different extensions you want to load with the viewer. For now, in this specific app, we are already loading one of the built-in extensions called Document Browser. But what I'm going to do is I'm going to add another string after that. And that's going to be the name that we chose when registering our extension class with the extension manager, right? In our case, we decided to call it My Awesome Extension. So I'm just going to take that string and append it here. And that's it. Now we can give it a try. Launch our app, head over to our application and reload it. And we should see when we click on an object in the tree, you remember when we were defining that extension in the load and unload method, we just used console log to output something to the console, right? So I open the viewer, see, my awesome extension has been loaded. So this is the point where the viewer, as it was starting up, was actually initializing and loading our new custom extension as well. Now it's not doing much. See, we now have this custom group with a new button in it. And when we click it, we just get the alert saying hello, right? So that's our extension skeleton. All right, that's for the, again, basic extension skeleton, right? Now, what I'm going to be doing is I'm going to be making copies of this JavaScript file to create other extensions with other names, right? And again, I'm going to put them in separate files so that, again, maybe in future they could be reused if somebody wanted to. All right, so let me add a copy of this extension file. And maybe let's, just to be consistent, let's head over to the LearnForge tutorial, right? So this is now, okay, we've gone through our custom extension skeleton. And now we're moving on to the other section, handling selection, right? So we're going to create another extension, and I'm going to call it differently. In this case, I'm going to call it JS handle selection extension JS. That's a mouthful. Handle selection extension. Handle selection extension.js. Again, feel free to name it maybe a slightly easier name. Just make sure that when you're then adding the script tag to your HTML, that it's referencing the same file name, right? And inside here, I'm just gonna go ahead and copy the content of this extension, copy the clipboard, and add it to my, oops, not this one, to my handle selection extension JavaScript file. All right, so we're creating another extension, again, deriving from the Autodesk Viewing extension class. And this looks very similar to the extension we created earlier, right? We're just going to log something during the load and unload. We're going to try and get the same control group, but we're going to be creating a different button this time. But we can probably style it the same way for now. I'm not going to be looking for other icons. So let me go back to our CSS, and I'm going to add another CSS rule for this new button that we've just created. And I'm going to reuse the same CSS properties, right? So there's going to be another button in the toolbar added by this handle selection extension, and it's going to use the same icon for now, but I'm sure you won't mind. All right, and again, in the on-click, nothing is happening just yet. But again, just to make sure that this extension is even brought into the web page and loaded, again, don't forget that we'll want to bring that JavaScript file to our page by adding a script tag. So I'm going to say JavaScript JS/handle selection extension JS, right? This way we make sure that the code for the extension class is actually brought to the browser and parsed by the JavaScript engine. And then in the viewer, again, we will want to make sure that that other extension is loaded as well. So again, I'm going to go back to the extension code itself. I see we have registered it under the name handle selection extension. I'm just going to add that string to the list of extensions that are passed to the constructor of our viewer object. All right. Now, going back to the LearnForge tutorial, again, we're just going to use the same icon in our case. You can use any image you want. We make sure that it's actually downloaded to the page, and we make sure that it's actually included in the constructor of our Viewer 3D class. And now, getting to the interesting part is the on-click function, right? This is the code, this is the logic we're going to execute when somebody clicks on that new button that we have just added. So let me copy the code and paste it inside the on-click function of our button. Just format it so that it's easier to read. And let's take a look at what we're doing here. Now we're using the viewer APIs, right? We're calling viewer.getSelection. Again, if you remember, this will give us a list of numbers representing the IDs of objects that were selected by the user in the 3D view. We then call viewer.clearSelection. So we basically unload, clear everything, right? So nothing will be selected. But we remember the list of IDs in this selection constant. And then if anything was selected, we go through the list, right? And for each selected object ID, we call viewer.getProperties. And you remember I tried that method in the DevTools earlier as well. right? We make this call to viewer.getProperties to retrieve all the properties of that specific selected object ID. We log them to the console, and then we use this built-in confirm method, which just opens like a modal dialog in your browser asking you for confirmation of something. We're just going to say, do you want to isolate some object? And to identify that object, we're picking the name and external ID properties from the result of the request, right? So when calling get properties, we receive back an object with all sorts of information about, that object with that specific ID. And one of the properties that, one of the informations, one of the parts of information that's available there is the name or external ID. So external ID is this concept for like uniquely identifying objects among different versions of the same design. In case of Revit, external IDs will be the Revit GeoIDs, right, of those specific elements. So we're just going to ask the user, do you want to isolate an object with this name and external ID? And if the user confirms, we're going to add the ID of the object into a list that we call isolated. That's empty for now, right? And we also call another API, another method on the viewer object called viewer.isolate, which means make that object visible and all the other objects invisible, right? We're adding this, we're calling that for the entire array. Now, the next time when we run this code for the next ID selected object in the list, right? If we call the isolate itself, we would just make that one object visible and everything else invisible, and that's not what we want. So instead, what we do is we add this new selected object ID to the list, and then we call isolate with that list. Right, so this is how we will step through every selected object. We will ask the user, do you want to isolate this object? And if yes, we will be building this array of these objects that have been confirmed, and we will call the viewer isolate so that only these objects will be visible and everything else will be invisible or ghosted. But if nothing was selected in the first place, we're just going to clear the isolation. We're just going to call viewer isolate with just 0, which means, unisolate everything, basically. And that's it. That's all the logic for our extension for this session. So let's give that a try. I'm going to reload my app, head back to our app, reload it as well. I'm just going to open the DevTools. Identifier handle selection extension had already been declared. That's probably, I probably saved the handler selection. Yeah, it's here. All right, so what I'm going to do for now is I'm just going to remove this my awesome extension because I accidentally renamed it. So I'm going to delete my awesome extension, remove it from here, and remove it from our list. And also I'll need to remove it from script tag, right? Because this file no longer exists. So now we will only have one custom extension being loaded into the viewer with just that button that will go through all selected objects, and it will ask us whether we want to isolate them or not. All right, so let's try that one more time. Okay, nothing is showing. That's good. The handle selection extension should only be loaded when we open the viewer. Right here. See? So we have still have our group with a single button. And now let's give that a try. So I'm going to select a couple of objects in using the Shift key. Maybe this 4, right? These 4 objects. And now when I hit that button, it'll get the selection and it will go through every single object ID, and it'll be asking us using a prompt whether we want to isolate that object or not. See, so now that's the first prompt. It's asking us, do you want to isolate basic wall 4287 with this Revit GeoID? I'm going to say yes. Okay, now the extension called the viewer.isolate method, right? So isolate caused the scene to basically hide everything except for the wall. Now, do you want to isolate floor, something, something, something? I'm going to say no. This time, I don't want to include this one. Cool. Now it's asking me, do you want to isolate another floor? I'm going to say yes. See, that's this one. And now it's asking me whether I want to isolate a basic wall. I'll try and say yes. There you go. Right? So now we ran through the logic in our on-click event handler of our button. And that's it. That's the first quick intro into viewer extensions. All right. That was for our demo time. So now let's see if there are any questions. All right, question number one. If I have more than one viewer in one page, how can I choose which viewer should work when I type NOP viewer? That's a good question. The NOP viewer is really a shortcut, sort of a hack so that you can quickly play and experiment with the viewer. But of course, if you have multiple viewers on the page, the NOP viewer will typically represent the last viewer that was instantiated, right? But you should, of course, not rely on that, right? It's really a proper way, as I can show you maybe in one of my sample apps, or maybe if you're using it here. A proper way is to really keep different. If you're using multiple viewers on your page, it's better to store references to them yourself, right? Not relying on NOP viewer, but just store them in your own variables. So for example, in my case, if I knew that my app was going to have 2 viewers on the page, I would just create 2 variables, right? Maybe one global variable called viewer and another variable called second viewer, right? So then I would not be using the NOP viewer shortcut, but I would be referencing the viewers using my own variables. So that was a good question. All right. I am getting this error. I can see model, but NOP viewer, get properties, something. Properties failed to load since model does not exist. That is strange. We may need to look at that separately, Saji. It's possible. One thing, if you're running this in the console, that's really weird. One thing that's possible, if you try and call something like viewer.getProperties too early in your code, then you can get an error because of timing problems, right? Because, oh, can you see my screen? I think you can, right? Here is, the standard JavaScript code, the client-side JavaScript code we used during day 1, right? And now, if I try to be, if I was too impatient and maybe I tried calling viewer.getProperties here, this wouldn't work. And why? Because it's only now that we started this asynchronous call to even load something into the viewer, right? So by the time we reach this call, no model has been loaded yet, right? So this is too early. If you want to programmatically somewhere in your JavaScript code retrieve the properties of your model, you actually need to wait until that model is loaded. And in this particular application that we built during day 1, the right place would be here, right? So here we're calling viewer.loadDocument node. That's the actual viewer method that will load the model, the data from Forge, the 2D sheets or 3D models into the viewer. And it's actually something called a JavaScript promise, which means that you can call this .then method on it to add any kind of function that can be called after the model is loaded successfully. So here, if you tried calling viewer.getProperties here, you would have a better chance of that the model and the properties would already be downloaded at that point. So Saji, double check that. I think that might be the problem, where you might be calling the getProperties method too early. All right. Another question. If we change any geometrical dimensions in viewer extension, does it reflect the changes in real geometry or CAD file? No. So that's also a very good question. The SVF file format, right? I mentioned that during the previous day. So for those of you who weren't with us then, when you start a converging job in the model derivative service, as I mentioned, it'll start extracting 3D geometries, 2D drawings, metadata, tree, scene hierarchies, thumbnails, and stuff like that. The 3D geometry is converted into a proprietary format that we call SVF. That stands for streamable viewing format. And that's the format that the viewer can actually load, right? That format is used for efficient viewing on the web. But that format is just a one way, right? You can think of it as a PDF, just like you can take your Word documents or Excel spreadsheets and turn them into PDFs and share those files easily with others. They can open them, without needing to have Word or Excel installed. SVF is similar in that sense, right? Where you can, using the Forge model derivative service, you can turn your designs into SVF, and you can then share that SVF in Forge Viewer with others who can view the models, and they don't need to have Revit or Inventor or SolidWorks installed, right? But just like with PDFs, if you make any changes to PDF, those changes are not reflected back to the Excel spreadsheet or to the Word document. So this works in the same way, right? It's a one-way operation of like going from Word doc to PDF. The same way here, in this case, we go from Revit to SVF. So making any changes in SVF will not be reflected to Revit automatically. There are ways, however, how to bring changes back to your original Revit or AutoCAD or Inventor models, and that is through another service in Forge called Design Automation Service. And that is something that's going to be covered tomorrow during day 4. All right, another question. Property geometry show only area, not coordinate. How do we get coordinates of a model? All right, that's a good question too. It's a bit more advanced, but for those of you who are already, going that far, let me show you something. I'm going to go back to my app, and I'm going to show all objects. So now let's say you want to start going really fancy, right? And you want to start exploring, you want to start browsing or going through the instance tree programmatically. And maybe you want to start reading the XYZ positions or bounding boxes of individual elements. You can do that as well using the viewer APIs. So let's say I'll find this cool little guy, and I want to find its position in bounding box programmatically, right? Because then maybe later on, maybe I want to change its position, or maybe I want to add another 3D object, or maybe a piece of HTML that will, like an annotation that will follow the guy whenever I move the camera, right? I can do that too. So let me show you. I'm going to say, first of all, NLP viewer get selection to find out the ID of that figurine, right? Next, what I'm going to do is, and this is getting more, again, this is the more advanced use of the viewer APIs. I'm going to get the tree that represents all my objects in the scene. I'm going to call it tree equals NLP viewer model get instance tree. So we're basically saying, we're calling a viewer API, we're looking at the model property that represents the Revit model that is now loaded in the viewer. And we're calling get instance tree. And now we have a new object that we can work with, tree. We can use it to say, okay, what is the ID of the root object? It's 1, right? And then we can use it to enumerate all the children of those objects to be able to traverse that hierarchy. And now I'm going to retrieve one more object from viewer APIs called fragment list. I'm going to call it frags. It can be retrieved in a similar way. I'm just going to say viewer.model.getFragmentList. So just like the tree that we retrieved earlier was representing the structure, the hierarchy of different objects in the model, fragment list describes all the geometries. It's a flat list of geometries in the model. And the fragment list itself has its methods, useful methods as well. So now what I'm going to do is I'm going to call this tree.enum node fragments. I'm going to say for fragment, for object number 4610, right? That's the forge ID of our figurine. And I'm going to give it a callback function where it'll be called for every fragment ID that belongs to this figurine. I'm just going to output it to the console. And I'm going to, the final one, true, means I want to call this traverse the 4610 object and all its children as well. If it's a group of objects, I'm going to traverse it recursively. All right, I think this should be enough. Boom. All right, so now what we've learned is that our forge object, this figurine with forge ID 4610, consists of a single geometry fragment that has the ID 263. Why this step is needed? That's because when you think about it, when you have, let's say, a door object in your model, the door can actually consist of multiple, like it can be a wooden frame and like a brushed steel knob, right? These would be two separate fragments. A fragment in Forge is basically a geometry with one type of material. But if you have a door, which is, when you click on the door, you select the entire door, the frame and the doorknob, right? But the doorknob and the door frame might use different materials, so they may actually be two fragments. So one object ID can correspond to one or more fragment IDs. That's why I made this call to tree.enum node fragments to find all the fragments that make up this figurine. There is just one. And now finally, going to your question, I can say, get world matrix. I can use this get world matrix, or maybe a better option. Frags get proxy. What was the name of frags? Well, maybe just get, which would be is a get viz mesh. So there are a couple of options. Maybe this one would be the easiest. When you call get viz mesh method on the fragment list, you'll just need the ID of the fragment that you're interested in. It will return a Three.js mesh that will contain all the information about that object, including a transform that includes the position of that object. But actually, I'm not seeing it here. I'm not sure why. Oh, here. Yeah, there it is. So one way to find position of objects in the scene, or even manipulate it, is by using the fragment list. Let me maybe show you the other way that might be easier. I'm going to create a new object called matrix, which is the matrix for object from Three.js. And if you're wondering what this means, Three.js is a open source library for 3D graphics on the web that Forge Viewer was built on top of. Since then, Forge Viewer replaced a lot of the functionality from Three.js with its own optimized rendering techniques, but some of the base classes like 3.matrix4 and 3.vector3 or vector4 are still available and used by the Viewer APIs. I'm going to create a new matrix object, and I'm going to call frags.getWorldMatrix. And I'm going to say I'm looking for a matrix of the fragment ID 263. And I'm going to provide the matrix object so that this method can populate it with its data with the proper transformation. And now if I look at the contents of the matrix, you can see these 16 values that make up our 4x4 transformation matrix. And from here, you can figure out the position, the scale, rotation, and everything. And similarly for the bounding box, right? Let me also create a property, variable called bbox. It's going to be an instance of another class from 3JS called box3. And I'm going to call fragment list get world bounds. And again, we're looking for the bounding box of fragment ID 263. And we want the method to store the actual bounding box values into our bbox object. And when we take a look at it, you see minimum, maximum, XYZ are the extents of this particular, this figurine in our scene. So that's the more advanced use of viewer APIs. All right. Another question or comment in the documentation, the toolbar, it says the script tag starts with /. It should not be there. It could. Let me go back to that. To here, it looks like it's possible that on the LearnForge website, the script tag will look like this, right? The difference between these two are that when used like this is a relative path, a relative URL, which means that this URL will be resolved relatively to the HTML file where the HTML file is located. This HTML file is at the root, right? It's open when you go to localhost 3000. So this URL would be resolved to localhost 3000/js/handle selection extension. If instead we started with the /, this means that this is no longer a relative URL, but an absolute URL. That would be resolved absolutely to the domain of our server, right? So the domain of our server right now is, or the host, is localhost 3000. So in this case, this would actually be resolved to the same thing, right? So if I used it this way, this absolute URL would be resolved to localhost 3000/js/handle selection extension. So in this case, since our index.html file is at the root, this would work fine. You could, however, run into problems if our HTML file was in some subfolder, right? Then the relative versus absolute URL resolving could cause problems. All right. Another question, what's the best way to share an extension? Sending only the JS file and changing the rest of files? Yeah, that's what we typically do, right? If we go back to the Forge extensions, Autodesk.io, what we do is we keep every extension in its separate JavaScript file. You can actually see that when you look at the tooltip of one of the extensions, let's say, I don't know, viewer in viewer, right? Typically, you'll find some links to learn more information. This actually just points back to a GitHub repo where all these extensions are stored, right? And that's really it. What do I know here, right? So here you'll find the JavaScript code with your extension. This is the viewer in viewer extension that we saw there, right? So you can just grab the class from here and the CSS and add it to your application, right? So you can reuse the classes from here, and then all you need to change in your Forge application code is just the list of extensions that you want to load when initializing the viewer. All right. All right, another one. How can I hide built-in functions or extensions in Forge Viewer, like measure or properties? Oh, that's a good question. But what you could do is, I haven't tried that, but I think what you could do is you could manually unload the extension at some point during the initialization process. So again, yet another method available on the viewer object is called load extension or unload extension. And these methods are used when you want to manually add or remove extensions at some specific point in time, right? So what you could do in your app is call call viewer unload extension, and provide the name of one of the default extensions that add the measure, or maybe not the properties. I think the properties may not be an extension actually, but for things like measure and section tool, those are. But let's give it a try. So what we can do is we can say viewer loaded extensions, and that will show us an object of all the extensions that are currently loaded into our viewer, right? And you will see that there is one called section, measure, explode, right? Those are the section, measure, explode. So what I can do is, these are their unique names. So what I'll try and do is I'm going to say NOP viewer unload extension. And for example, we're going to try and unload the measure, right? When we do that, you see that the measure extension has disappeared. We can try unloading the section tool as well. Now see it disappeared as well. All right. There's only one way right now. Yes, that's for the SVF. If the CAD file is in Autodesk Cloud, and if any modifications done in CAD, does it reflect in current SVF? It can, yes, but you'll need to trigger another translation job, basically, right? So if you're trying to build a sort of a configurator experience, that can be done today with Forge as well, but it involves a bit more work, right? What we see, what sometimes our customers do is, let's say you want to build some configurator around your Revit models, right? You want to add the ability to maybe select this figurine, move it around a little bit, right? Shift it to the right, and then maybe hit some button that will send this update back to Forge. In Forge, we can apply this update to the original Revit model, and then we can use Forge to generate another SVF from the updated Revit model and load it back here. So it's this round trip that you'll need to cover, but yes, that's how you can get a configurator-like experience. And again, manipulating the actual Revit or Inventor or AutoCAD files in Forge is going to be covered tomorrow during the day 4 when talking about the Forge Design Automation Service. All right. I'm finding if I use NOP viewer get selection, I get nothing back. But if I use NOP viewers 0, that get selection, it works. That will be most likely some the issue we discussed earlier, where there might actually be multiple viewers instantiated on your page, and it can be either intentionally or maybe unintentionally due to a bug, right? And in that case, if you have multiple viewers instantiated on your page, when you call NOP viewer.getSelection, you may be referring to the other viewer, right? But if you type NOP viewers 0, that basically means, you know, that way you're probably able to catch the right reference to the right viewer where you actually selected something. All right, another question. Do you think Forge will move away from Three.js in the future, maybe for a different library or in-house build? Oh, that's a $1 million question that we discuss all the time and we fight over all the time, even internally. Yes, people ask us all the time, like, is it going to be able to use the viewer without Three.js, or at least with a newer version, more modern version of Three.js? And for now, the answer is still no, unfortunately. We are aware of this problem, that the Three.js library used by Forge is kind of outdated, and that is basically causing not problems, but some inconveniences to our customers who want to use maybe some more modern features of Three.js inside Forge Viewer. But today, due to the way it's been designed, and it's very difficult to move Forge Viewer to a newer version of Three.js or away from Three.js entirely. So we are aware that this is a problem. We're discussing, the best way to address that. But for now, we don't have a solution and we don't have an answer for that, unfortunately. All right. One more. Would you be able to show us some materials and color manipulations? So again, I would say, because this session took a little bit longer, so I would say at the end of the final session, session 4, if there is time, we can take a look at some additional customizations of our app today, right? So there was a request to maybe show a drop down with different properties for the dashboards. So let's, we can look at that. And then if there's some more time, we can try some additional viewer customizations, like changing materials or colors of objects. All right, another question. Would there be something built on React and TypeScript? So we don't have an official wrapper for React just yet, but there are plenty of samples for, and many of our customers are using the viewer in different environments, like in Angular, inside React, or inside Vue.js. We know that, these frameworks, even though it is true that React is like the winner in the popularity, we know that there are different frameworks, and frameworks disappear and reappear. So we try to stay agnostic. We try to keep Forge Viewer basically just a vanilla JavaScript library that you can integrate into any JavaScript UI framework that you might need, whether it's, again, Vue.js, React, or Svelte, or the next framework that will appear, that will show up next month. So we know that some of our customers or the Forge community is actually maintaining Vue.js wrapper and React wrapper. You'll find them on GitHub, but those are not official wrappers maintained by us. Those are, those belong to the community. All right. Thank you. I want to use this XY coordinate for a 2D model. I use curl terminal for getting OBJs, but somewhere it gets stuck. Okay. All right, I'm not sure I understand. So I'm going to use this XY coordinate for 2D model. So maybe getting coordinates from 2D models, like 2D drawings. That should work in the same way as the approach I demonstrated earlier, because even if you're looking at a 2D drawing, you're actually in 3D. The only difference is that the camera is set to orthographic mode, and it's locked so that it cannot orbit. It can only pan on top of your 2D drawing, which is just a plane in 3D space. So you should be able to use the same methods to get fragments and their positions. I actually, we even have a blog about that. So let me see if I can find it. Blog. Geometry, maybe. Yes, working with 2D and 3D scenes and geometry in Forge Viewer. This is a blog post I wrote back in 2019. And it explains this advanced use of the fragment list and the instance tree and all of that, how it can be used to both read as well as manipulate the transforms of the objects in your model in the viewer. Let me paste that into the chat in case anyone finds it helpful. All right. Technical debt might be a good argument in those meetings. That's certainly true. Yeah, this is a very, and for me personally, even, it's a very critical topic that I've been sort of like trying to figure out because I also work as a developer on the viewer team, and I felt that need for, moving away from the old version of 3JS, so to either be able to use a more modern version or, again, abandon it entirely. Now it looks like we have two camps internally, where one camp is sort of fighting for, well, let's just ignore 3JS entirely, and the other camp is trying to stick with it, say that 3JS is really, really popular, and really many developers know the interface and the APIs of 3JS. So it would be a shame if we threw all of that away, and if we came up with our own vector 3 and vector 4 and matrix 4 and object 3D classes that people would have to learn from scratch, basically, right? So it's an ongoing discussion. It's a tough discussion, but yes, it's something that even personally I feel very deeply involved in, and I want that to be resolved. All right. No other questions I see. In that case, it's your turn now. This one took a little bit longer, so we'll now have roughly an hour before we meet again. So what you want to do is, experiment with adding viewer extensions to your existing Forge applications. Again, when adding an extension, don't forget that after implementing the JavaScript code, you'll want to make sure that the JavaScript code is actually loaded into the HTML, that the extension is registered under a certain name, right? And that when you're instantiating your viewer, that you pass the name of your new extension into the constructor, as the config property. And then second, try and experiment with the selection and isolate the different APIs, right? Like using viewer.getSelection or viewer.isolate to see, if you can read the information and again manipulate the state of the viewer programmatically from your extension's JavaScript code. All right, and we will see you back here in about an hour. If you run into any problems, if you have any other questions, post them in the Q&A in Zoom, and we will be taking a look at those as we're available with Deepali, and we'll answer there. All right, good luck and see you in an hour. Okay. Hello, everyone. Welcome back to session 3 of our webinar today, where we talk about extending the Forge viewer and building dashboards with your model data that you can extract using viewer APIs. That's our topic for the 3rd session. There were quite a lot of questions at the end of previous session, but now again, if you ran into any problems while following our steps, adding your first basic viewer extension or using the viewer APIs like the selection and isolation, now's the time to ask. And if there are no questions for now, we can move on to our task for session 3. So what we're going to do now is we're going to add yet another extension that will this time expand our understanding and our knowledge of the viewer APIs by actually creating additional UI elements, specifically a panel that looks similar to the properties panel, for example, that you see that is enabled in Forge Viewer by default. And what we're going to do for that panel is we're going to use the viewer APIs to extract information, again, the properties from our model, and to calculate some sort of a histogram or summary of how many objects have a certain property set to certain value. And I'll explain what I mean by that in just a second. And then we're also going to start preparing our data for the final session today, where we're going to start adding the actual dashboards. So we're going to prepare a little bit of JavaScript code similar to the one we're using in the docking panels. That's going to then be used to actually visualize some kind of summary in a bar chart and a pie chart. All right, demo time. Let's move back to the Learn Forge website. And again, today we're working on this viewer extension tutorial. And right now we're looking at the docking panel step. So what we're going to do, one more time, we're going to create another JavaScript file in somewhere in our Forge application code where we store our client-side assets, HTML, CSS, and JavaScript, right? So that that file can then be easily loaded to our HTML, to our page. So let me copy this code snippet to the clipboard, and we're going to create a new file called model summary extension in our Java, in my case, in the Java.js subfolder. We're going to call it model summary extension.js. Pass the code here. So again, we are creating yet another extension class deriving from Autodesk Building Extension with some basic load unload setup, creating a button in a toolbar, and not doing anything yet on click event, right? And we're registering the extension under a specific name, in this case, model summary extension. All right. Now, again, for now, I'm just gonna reuse the same image for the button. So let me just copy this CSS class name and go back to my CSS style sheet and add that as another rule at the end of our CSS. So we're saying that any HTML element with this model summary extension icon class will have certain CSS properties, specifically a background image of a specific size centered without repetition. That's just to style the button, right, in the same as earlier. And again, one more time, we must not forget to first make sure that this file, the JavaScript file, is actually loaded into our HTML. And we do that by adding a script tag it's recommended to put it in the head tag. So that is the model summary extension.js. So now with this, we know that the new class that we've defined will be loaded into our page. And the second part is we also need to make sure that this extension that we have just registered, that we actually load it when starting the viewer. So I'm going to go back to the code where I'm actually instantiating our GUI viewer 3D class. And I'm going to add the new extension name to the list of extensions that we're passing in this config parameter, the second parameter to the constructor. All right, that's it. Right now, our new extension is going to get loaded, and it's going to add its own button into the toolbar as well. We can quickly double check that. I'm going to start my app, head over to localhost 3000. Make sure that when we open a model, we're going to see two buttons in our custom toolbar group. And there they are. This is the original button from the extension we implemented in the previous session. And now this button is not doing anything yet. This is where we're going to show the new docking panel, the panel interface with some data and summary that we've calculated from the properties of that specific loaded model. All right. Stop the app and go back to the LearnForge website. This is our extension. We've already added some basic CSS to style the button. We've added the extension to our HTML markup and added it to the constructor of the viewer. Now, it's helpful sometimes when you want to do things like compute certain analytical data or statistics for objects in your model. Quite often, it's really helpful to be able to get the list of all the leaf nodes, or leaf components is what we call them. So right in your model browser, when you see the tree structure for your design, sometimes it's helpful to be able to identify which are the leaf objects, meaning objects that don't have any other children. Right? Because when you want to compute some information about, again, maybe some compute a histogram for property values, right? You only want to compute them for the leaves of your object, meaning not for groups, but only for objects that don't have any more children. So we call them leaves, and in order to be able to retrieve those, we're going to add this helper function or method to our new extension class. I'm going to copy this get all leaf components method, and I'm going to add it to my new extension. That's the model summary extension that we've just created, right? So it's just a method that I'm going to be able to use, call later on to retrieve all the leaf nodes from my tree, from my model's tree. You can see this is going to be an asynchronous method that when ready will call some kind of a callback function. And what it's doing is yet another piece of API, viewer.getObjectTree. That's basically the same thing as calling viewer.model.getInstanceTree, but in this case, it's asynchronous, right? So this might be a better option when you're not sure whether the model that you want to get the tree from has already been loaded or not. So sometimes you'll find APIs in the viewer that are synchronous that you can call when you know for sure that the data you're asking for is already there. And in many other cases, like the get properties API, right, the get properties method on the viewer object, those are asynchronous, meaning that you will need to pass in a callback function that will be called later when the data is actually available. So what we do here is we retrieve the object tree or instance tree, right? That's again, the data structure that gives you information about all the parent-child relationships in the tree hierarchy. And what we're going to do is we're going to call tree.enum node children, meaning enumerate all the children of a specific node. And in this case, we say the root node, right? That's the top level node. And for each child that we enumerate, call some kind of code. And then we're also passing in a third parameter Boolean flag, a Boolean value true, meaning run this operation recursively, meaning that if those children that we've enumerated, if they themselves are groups, then call the same function for its children and their children as well, right? So this is the true flag will make sure that whatever code we have in our function here is going to get called not only for the children of the root, but for all the nodes in the entire tree structure. And what we do here inside the function, we just ask the tree structure, hey, does this node have any more children, right? And if not, that means that that's the leaf that we're interested in. So we add it to a list that is empty at the beginning, right? So we iterate the entire structure, all the nodes in the tree, and we check if they are leaves, meaning if they have no other children connected to them. And if that's the case, we add the ID of those objects to our list, which we then, at the end of this operation, we call this callback function with the array of all the leaf nodes. All right, that's for the helper method. Next thing, we're going to add the actual class for our new UI element for the panel where we're going to show the summary, the histogram data. So let me copy this docking panel snippet as well into the clipboard, and let's add that class after our extension class. All right, so this time we're defining a class called model summary panel, which is extending a different class, autodesk.viewing.ui.property panel, right? So the viewer APIs not only give you the viewer 3D class that gives you access to the methods like get selection or isolate or get properties, but it also includes some set of UI elements that you can use, like the toolbar, right? Or the UI button, or again, a panel or a property panel, which is a more specific type of a UI panel that will contain 2 columns with some property names and some property values next to them, right? We could also use just a generic docking panel and just place some arbitrary custom HTML inside it. But now we're going to use this more specific class to get some, some of the layout for the 2 columns with property names and property values, to get that functionality out of the box. And all we do here, we just override the constructor, or we store a reference to the viewer. That's it, right? We don't need to do anything more specific at this point, right? For our panel class, we can just leave it like that. All right, heading back to the Learn Forge website. Finally, we can move on to the core of this step, and that is implementing the logic inside the click event handler for our new button that the extension is adding to the toolbar, right? So let me copy this snippet again into clipboard and add it to our on-click event handler. All right, and now let's take a quick look at what's happening there. When the user clicks on this new button in the toolbar that our extension added, we're going to check if there is already an instance of our new UI, the new panel, right? And if there's not, we're going to create one. So we simply call the constructor of the new class that we defined earlier, the model summary panel class. We create a new instance of that and store it in a member variable called _panel on our extension object. And we then call one of the methods of the panel that we get from the parent class, from the property panel class, called setVisible or isVisible. So we basically use this to toggle the visibility, going from hidden to shown, visible, and from visible to hidden. And if the panel, after the toggle, if it's not visible, we return without doing anything. And now the important piece. Next thing is we call our helper function on the extension class, right? The one that is supposed to go through the entire tree of our model and find the IDs of all objects that are leaves, meaning objects that have no other children under them. And it will call a callback function that we specify here with the list of these IDs. And now the important part, what we do here is we define a bunch of property names that we are interested in. For now, these are called property name A, property name B. We will get back to these in a moment. Now, if you remember earlier, I was using this method, API on the viewer class called getProperties. But if you remember, that one only accepted a single object ID, right? And it returned all the properties for that single object ID. But sometimes there are cases where you want to retrieve properties for multiple objects, right? And calling the getProperties method for every single one of them in a loop would not be efficient because there's actually a boundary where the request for retrieving properties actually goes to like something called a worker thread. So there's, data needs to be sent between different JavaScript contexts, which takes time and resources. So it's better if you need to retrieve properties for multiple objects to use another method, and instead of getProperties, to call a method on the model object itself called getBulkProperties. That one accepts as its first parameter not a number, but a list of numbers, right? And these are the numbers we receive from our getAllLeaf components, right? So these are going to be all the IDs of all the leaf objects in our model. And what's even better, when calling the getBulkProperties method, you can also specify just a filter to only filter the properties that you want to retrieve. So maybe you are not interested in receiving all properties for these objects, but only some specific properties. In this case, you see, we're asking the viewer to only get us these two properties, property name A, property name B, from our leaf nodes. And again, we're passing in a callback. So when this operation is successful, we receive something, a response with an object. And that object is going to be an array where each item in the array will include the database ID, the ID of the object, and its property. So it's going to include things like item.dbid and item.properties. And then what we do, we go through all the properties of every object that is returned to us by the getBulkProperties method. And we start building this data array. Actually, that's interesting. Yes, okay. We start building this data structure in memory where we're going to keep, basically it's going to be a top level object with properties that represent different property names retrieved from our model by the get bought properties, right? So the elements in your model, they may have properties called material, right? And the material property can have values such as glass or concrete or whatever have you. So in this structure we're building in memory, we're going to be adding basically, so let's say we get a material property, property called material. We're going to create a new field on our top level object called material. And inside it, it's going to be another JavaScript object that's going to contain and the keys of that object are going to be the different values that can be set to the material property. So concrete, glass, wood. So that's going to be a nested object. And each value for that key is going to be an array of numbers representing the objects the number of occurrences of that specific property name and value. So this is a bit confusing. So let me maybe explain it during runtime as we populate the structure in the DevTools. That'll make more sense. All right. And finally, what we're going to do is we're just going to then iterate this computed histogram of how many times, let's say, the material property was set to wood and how many times the material property was set to concrete. And we're going to add these results to our custom UI panel as a property. So since our class is derived from property panel, it has some additional methods, one of them called add property. And by that, you can just say, I want to insert a new row into my panel. That's going to be some property name, property value, and potentially a category. That's the third option here. So that's where we're going to show that, let's say, concrete appeared, I don't know, 10 times, right, in the material property, and wood value appeared 15 times. So that's what we're going to show in the panel. All right. And I believe that is it for our extensions. Let's give it a try, run our app. Localhost 3000. I'm going to open the DevTools one more time. All right. Let's see. We're going to load our model. And well, now probably nothing will happen. We'll probably won't see anything because that's fine, right? So we do see our panel, but it's empty now. And the reason for that is these property name A, property name B, right? So these are just placeholders. We will want to find out some specific property names, depending on your own model that you're viewing, that we will want to compute the data for, right? The histogram for. So let's see. Let me open the properties dialog and see what types of properties I see here. So I see that maybe material would be a good option, right? So in this case, that object has the material property set to grass. Maybe there would be a material property. Now let's see here for the floor. Let's see. No, maybe that's not the best property to compute the summary for. Let's see. Anything. Maybe the level would be a good one. Finishes. Trying to see which one would make the most sense. Yeah, maybe a level. Let's just for now, since I'm using this Revit model here, it looks like level property is pretty prominent in different elements in our design. So let's try level. I'm going to go back to my code and replace these two guys with level. So what that means is now when we call the get bought properties, we're basically asking the viewer to give us the level property of every one of these object IDs. So let's try that. And one thing I'm going to do is I'm going to put a debugger statement here, which means that it will actually stop the execution of the JavaScript code in the browser as if we had put a breakpoint in there. All right, so let me open the Revit model and use our new extensions button. Boom. All right, so now we hit the debugger statement. Whoop. Where is it? Here. Debugger statement, right? So now we should already have a list of all the leaf nodes of our model. And here it is. So there's 439 objects in our tree that are leaves, meaning objects that have no other children. And now what we're going to do is we're going to say, okay, now we're asking the viewer to give us the level property of all these 439 objects. So I can put a breakpoint inside the callback of the getBlockProperties method. Boom. And then you'll see that the items didn't return 439 results. That's because for some objects, maybe they don't have this level property specified on them. But for 402 objects of that complete set, the viewer was able to find the level property on them. And we can take a look. You'll see that, okay, so let's say the first item in the response in the array contains a DB ID, that's the ID of that specific object, and properties, and it actually contains two, see, level and level. And the name of that property is level, and the value of that property is level 1 in this case. For others, it may be level 2 or level 0 maybe. So now what's going to happen is we're going to start counting the occurrences again for that specific display property name, that's the level, and then for the specific display value, right? So we're going to fill this filter props object with the occurrences. So let me put a breakpoint here after that for each is done. And now you'll see that, okay, perfect, right? So you'll see that at the top level, we have a property in our object called level. That's the name of the property that we are computing the occurrences for. And inside here, you actually see the different keys of that object are the different values that we found in the property metadata, right? So some objects had the level property set to 2. Some objects had the level property set to ceiling. Other objects had the level property set to foundation. And you can, and the numbers are the actual occurrences, right? How many times we found, so there were, let's say 40 objects that had the level property set to 7. And now that we're done with computing these occurrences, right, we will simply iterate over them and add them to our panel as additional properties. Boom. Right, so now we have our new fancy UI panel here, showing the occurrences of different values for the level property. We can try extending that. If we go back to our JavaScript code, maybe we can try the material after all. Right, so now our code is going to be looking for the occurrences of different values for the level property as well as the material property. So let's try that one more time and see how much we find. Material, perfect. All right, see? So our new fancy extension has found 144 objects that have a material property set to metal, paint finish, dark gray, matte. All right, that's the first part of our session. Again, learning how to leverage the viewer APIs to compute different stats out of your model and display them in some kind of a UI, native UI to the viewer. Now, let me stop my app and can move on to the second part, of our session, and that is the preparation of data for our charts, our dashboards. So now we're actually skipping ahead, moving into the dashboard tutorial, and we're going to start by this prepare data with this prepare data section. So here's what we need to do. Again, this is very similar to what we've just done, right? Earlier, we were basically building an object in memory, a JavaScript object that at its top level, its keys represent the different property names. And then for each of these objects, their own keys represent all the possible property values. Now, in the extension that we've just built, we've been just counting the occurrences, right? Just storing a number telling us how many objects have this property set to this value. But now we're actually going to store the IDs of these objects, and you'll know why soon. So let's start by preparing the first piece of logic for our dashboards. We're going to create a new subfolder for all our JavaScript files for the dashboards to keep them nice and separate. So in my case, again, since I'm using the sample app from day one, I'm just going to create a new subfolder called dashboard in our JS folder. And I'm going to create a file called dashboard panel. Let me copy this snippet to clipboard. And again, in our app, our JS folder, I'm going to create a subfolder called dashboard. And inside there, I'm going to create a new file called dashboards. Now let's take a quick look at what's happening here. So dashboard panel itself defines a generic HTML element that we're going to host our charts, our dashboard charts. And then our panels. And then there is a more specialized class derived from that one that will actually be used to store charts as part of our dashboards. And this is where we're going to start preparing the data in the structure that I just explained, right? With the, again, the top level object containing keys representing different property names. And under those keys, you'll find other JavaScript objects with keys representing different property values. And then under each key, you'll find an array of object IDs that have IDs of objects that have this property set to this specific value. So that in here will be constructed using a helper class called model data. This is something we're gonna pass in to our dashboard panel chart class instance as part of the load method. And what it's going to look like here, the model data, the helper class, we will just call, exposes an init method that does something very similar to what we just implemented for our model summary extension, right? So it collects all the leaf components, all the IDs of all the objects that are leaves and have no other children. And then it iterates over all of these IDs. And in this case, it calls get properties individually, right? So this is the less efficient approach. Calls get properties, retrieve all the properties of every specific ID from the list of all the leaves. And here, it will actually try and compute the stats, again, like building an actual array of object IDs that have this property name set to the specific property value. There's also a little bit of normalization where if it detects that it starts with, if the category starts with angle bracket, it'll skip it. So this is just some, potentially, maybe there are some properties in the models that we do not want to include into this computation, right? So for that case, we would skip them. And now, as you can see here, slightly different to the extension we implemented a moment ago, Here, we're not actually asking for a specific property. Here, we are actually computing the histogram for all properties available on each of the leaf objects. All right, and a couple more helper functions that we're going to use later, right, that we can call on this model data class, helper class, to try and find out if it contains any, this specific property with its name, if, how many objects have this property name, and how many objects or which objects have this property name set to this property value. So that is something we're going to use later on in the final session. And again, don't forget to bring this new JavaScript code into our HTML page, right? So let me go back to index.html and add another script tag pointing to js-dashboard/dashboard panel.js. So that's it. That's it for this session. Again, in the final session, session 4, we're gonna add the actual charts that will show data based on whatever summary is computed by this model data class. All right. Now, time for questions, and after that, your turn for implementing these two pieces of functionality into your Forge application. So let's see, I don't see any questions, but something in the chat. All right, so that is, all right. One of you couldn't hear me. Hopefully that was not a problem on my end. But other than that, it looks like we're good. Okay. All right. Any other questions? If not, then okay, now is your time. And again, you have about an hour and a half to follow our steps from this third session. So adding your extension that adds a docking panel and that shows the number of occurrences of different property values for specific properties like material. All right. There is a question, how do you control the position of the chart in the HTML? We can elaborate on that when we get to that point. That's something that we're going to cover in the 4th session. We will just basically change the, at least in the sample that we're following on the Learn Forge website, we're just going to decrease the width of the Forge viewer, and we're going to use jQuery to add one more div to the right of it. And that's going to be the real estate where we're going to start adding our charts. So again, we can explain that in more detail when we get to that point as part of the session 4. And there is one more comment. This is something similar to Forge design automation. Not sure if I understand what exactly you mean by this. Something is similar to Forge design automation. Maybe if you could elaborate on that a bit more. Basically, we're making design automation. Not quite. I mean, to me, when you say design automation, what I understand under that term is some automated pipeline, a piece of code that automatically reacts to events that may happen in the Forge ecosystem. For example, when a new file is uploaded to BIM 360, or when a new file appears in a bucket somewhere in the Forge data management service, right? Then that automated logic will download that new file, and it will automatically process it with some custom Revit plugin or with some custom AutoCAD script. And then it will maybe generate some results, maybe some text file or spreadsheet, or maybe an updated version of a Revit file, and it will upload it somewhere as a result automatically. That is what I understand as, design automation, right? Where you can have like model checking, for example. Model checking would be a good example of design automation, where you can set up your Forge design automation pipeline that will automatically run when somebody uploads a new version of file to BIM 360, let's say a new Revit file. Your design automation pipeline can grab that Revit file, run some model checking logic on it with your custom Revit plugin. Maybe it detects that there are some problems, so it can output a text file or a spreadsheet with some information about what's wrong, and it may upload the spreadsheet somewhere and maybe send an email to the user who uploaded that file, letting them know that there is something wrong with it. That is what I understand with design automation. Right. And there's another question. Is it possible to upload larger files to the application? At the moment, I get an error if my model is 90 megs. Yes, definitely it is possible. It is actually recommended. Forge and the Forge Data Management Service, let me find it here, supports something we call a chunked upload. That means you create a sort of a session with Forge, and you start uploading your one file in chunks in the context of that session, right? Let me find it. If you go to Data Management Service, API reference, you will see that apart from the standard methods like this put request, that basically means upload an object, right? But you can also see that for objects larger than 100 megs, we recommend using this other endpoint, which ends with resumable. Let's find it here, resumable. So as it states here, this endpoint allows you to upload large files in chunks in a resumable way, right? This has multiple benefits. One of them is if that file is really too large, you don't want to, I mean, that connection, that process could easily time out, right? If the file was too large, it's possible that the server connection would time out before you'd be able to upload the entire thing. And also another reason, probably even more important one, is let's imagine that you are building an application that will try to upload a 1 gig file of your user to Forge, right? It'll take some significant amount of time. The upload will get to 80%, and then maybe your user's internet connection drops, right? And then the whole thing is lost, and they would need to upload the whole thing again. So even from that reason, it's good to use the chunked upload, because that will also allow you to resume your upload if anything goes wrong, right? That is something I'm also using in the Forge extension for Visual Studio Code. So if I upload a file, let's see, Forge training bucket. So let's say I want to upload a file that is maybe too large. I'm not sure if I'm gonna find a good example. So I'm gonna upload a Revit file, and maybe I'll change my mind and maybe let it upload a little bit. See, and maybe somewhere halfway through, my internet connection drops, or I realize that, oh, I need to close my laptop and take it somewhere else. So I'm going to cancel the upload. But check this out. If I try and upload the file with the same name into the same bucket, Revit, now which one was it? Was the first one? And I give it the same name. See, it actually found out that part of the file is already uploaded as part of that session. So you even get this nice resuming and cancellation and resuming functionality to your file uploads. So it's definitely recommended, even when dealing with files that are maybe tens of megabytes in size. All right, one more question. Are there more visual element types that can be added with extensions apart from toolbar buttons and panels? For example, points at the model. Some that I'm guessing you mean like custom 3D geometry, or maybe point clouds and things like that. Those can also be added. There are different ways to do that. As I mentioned earlier, Forge Viewer is based on this open popular library called Three.js, and you can actually create custom Three.js 3D elements. Like, you can load in, like, either create like spheres and boxes, or you can load in some additional geometry, maybe using GLTF. And you can add this custom geometry into the viewer as well. So that is certainly possible. Another option, and when talking about UI, you can also overlay your 3D canvas with HTML elements. And you can have those HTML elements follow specific positions in your model's 3D space by using some viewer APIs as well. Now, let me think what would be a good example for extension. Oh, sorry, showroom. There's another page called forge-showroom.autodesk.io that lists some of the samples we have available that showcase different types of functionality of Forge Viewer. There are a couple of things. I'm trying to see if there's maybe one where we are inserting 3D geometry. That would be a good. Or here's an example. This is a sample that all of these you'll find, well, most of these you'll find on GitHub. This is a sample where we actually bring in a poetry, which is a popular web-based format for point clouds, and we're adding the point clouds into the scene, into this Revit model, right? So that's one good example. And we also have this other one. Let me show this one. Live demo for the digital twin, where you can see the other approach that I was mentioning, where you can overlay your object. Well, there's too many of these, but you can overlay your 3D canvas with standard HTML. These are just HTML divs, and we're using the viewer API to make sure that these divs follow some specific elements in the model, right? So if I, for example, explode the model, the different annotations follow the corresponding shapes. Or maybe if I'm not sure if I added like isolation functionality. Isolate, yeah. So I only showed the annotation for that one bolt that I isolated, right? So again, this is better in cases where maybe you want your custom UI to be more interactive, like you want to have images or links, make them clickable, right? In that case, having a 3D geometry inside the viewer would not be as helpful. But being able to actually take some custom HTML and stick it to some 3D elements might be a better option for you, right? But yeah, definitely you can add custom 3D geometry to the scene as well. And for that, I'm thinking maybe the Forge blog would be the best source, because I think we may have some blog posts on that topic as well, adding custom geometry to the scene. And you'll also, actually, one good resource would be, we go back to the viewer reference, and we look at the developer's guide. You'll also find these viewer essentials and advanced options. And under the advanced options, these are again like tutorials provided by the viewer team itself, you'll find this section called Add Custom Geometry. And this is pretty much what, probably a very good starting point for what you're asking for. So what will happen there is you'll see that in your code, you can just create a new kind of 3JS geometry, in this case, a sphere, give it some kind of 3JS material, in this case, mesh basic material, and you can, create some kind of a 3JS object. And then using the viewer, it has something called an overlay or overlay manager. You can say, I want to take my viewer and I want to take this custom mesh, this sphere with red color that I created, and I want to add it to some kind of overlay called, in this case, custom scene. Right, so that can be part of your extension functionality as well. So you can have custom 3D shapes, add them to the viewer to maybe indicate some sort of, some kind of information. All right. Yes, I see there's one more question, but that one we'll probably need to discuss. So unless there are no other questions, we can move on to our please stand by. Now you can take your time to work on these steps, and we can see you here in an hour and 10 minutes. And in the meantime, I'm going to stop the recording. All right. Hi, everyone. Welcome back for the final session of our webinar today, where we're going to tie everything together, and we're going to take the data that we computed as part of session 3 today. We're going to show it in form of a couple of charts in our Forge application. All right, one more time, time for any questions. Again, we had quite a few of these at the end of the previous session, but then again, if you ran into any problems or you have some comments about the steps covered in the previous session that you want to bring up now, go ahead. We'll wait for a little bit, and if there are no other questions, we can move on to our goal for this final session. And that is, first of all, updating the UI of our app. And again, this is something that may vary depending on what starting application you're using. Again, we're going to be starting with starting from the app we built on during the day 1, and it's actually going to be the same for day 2. But don't worry, if you are integrating dashboards into your own Forge application, that'll work too. There's really just a little bit of setup that needs to be done, creating a div element somewhere in your layout with a specific ID, and that one is going to get populated with the dashboards with our data. All right, and we're going to add like a basic bar chart and pie chart showing the occurrences of different property values, right, in the metadata of our design. All right, final demo time. Let's go back to the Learn Forge website. And again, we're looking at the final tutorial dashboard. This time we're going to be, first of all, we're going to be adjusting the layout. Let's see how we do that here. We're going to create one more JavaScript file, client-side JavaScript file in the dashboard subfolder that we created earlier. This time we're going to call it dashboard.js. That's going to be the top level class representing the entire dashboard that lives on our page. So let me copy this code to clipboard, head over to my VS Code, and again, under the dashboard subfolder, I'm going to create one more file called dashboard.js. We're also going to make sure that this file is loaded in our index.html. Dashboard.js. All right. Now also the order will be important here because let me take a look at the dashboard.js. well, actually in this case, maybe it's not that critical. You'll see that we will be referencing some additional classes from here as well. Like in this case, Autodesk Viewing geometry loaded event, right? So make sure that the dashboard.js file is included after the viewer JavaScript library itself. All right, so let's take a look at what's happening here. We once again use this jQuery construct, right? We're creating a jQuery wrapper for document. That's the object representing the entire HTML document. And we're adding a listener to this ready event. So as soon as the event is ready, we're gonna create another event listener. And this one, this is a bit trickier, but still, I think, easy to follow. It's, we're gonna add an event listener for an event called DOM node inserted, right? So this is an event that's gonna be triggered by the document, by the HTML document, whenever some HTML or DOM node is being added to it. And we're going to use that to basically find the right timing to initialize our dashboard, right? So we're basically checking when the node that's been inserted includes a CSS class called orbit gizmo. So that basically means once we've inserted our viewer object, right, we're going to check if the viewer is available. And if it is, we're going to create a new dashboard. That's a class that's defined in the same file here. And this is the class that represents the entire dashboard that may include one or more dashboard panels, which can be charts or other things potentially in the future. Right, so for now, what we're doing is we're going to create a new dashboard that's going to fill up certain part of our HTML with its own content. And we're going to initialize it with two charts, a bar chart and pie chart. You'll see we're passing in some kind of string material. It's actually going to be the property that we want to show the data for so that we can customize it later. The dashboard itself, you'll see that when we call the constructor, we adjust the layout. This is actually the important piece that you'll want to be careful about if you are maybe using your own Forge application, to allocate some real estate in the HTML. And then we're also adding an event listener to the viewer itself. We're going to wait until a model completes loading, right? So this Autodesk.viewing.geometry loaded event is one of the many events that the viewer itself triggers at different points in time. This event specifically is going to get triggered when the model completes loading all of its geometry. So we're going to wait for that moment, and when that moment happens, we're going to populate the dashboard and actually show the panels with the, in this case, with the bar chart and the pie chart. All right, so that's for adjusting the layout. You'll see here, basically what's happening is we're gonna get the element of the sidebar, right? So this is the first element in the row is going to be, that's the sidebar we use for the tree in our case. So we're going to remove the CSS class SM4, replace it with SM2. So these are classes coming from the Bootstrap CSS framework. So we're going to basically change the width of the sidebar from 4/12 of the area of the entire width to 2/12 of the entire width. So making it, half the width. And we're also going to take the panel, the div container containing the viewer, and we're going to change it from 8/12 of the entire size to 7/12 of the entire size. So again, making it slightly smaller to make room for the dashboard on the right. You can actually see that here, right? This is the important piece. After we change the Bootstrap classes on our HTML elements, we're going to call this after method to basically add a new piece of HTML after that. And that's going to be a new div element with the ID dashboard. So again, this is the breaking point. If you are using your own Forge application, all you want to make sure of when integrating these dashboards into your app is that you have this, you can replace this code basically with any custom HTML manipulation logic you want. You'll just want to make sure that after calling the adjust layout method, that there is going to be a div element somewhere on your page, and that div element will have the ID dashboard, and we will use that later to populate it with our dashboard panels, specifically with charts. You can actually see that here, right? This is where we're finally getting to use the model data. If you remember, that's the helper class we used earlier. We defined in the dashboard panel class, model data, right? That we're using to actually compute the occurrences of different property values. This is once again important for the timing, right? So since in our dashboard, we'll be relying on model data class, it's a good practice to load it earlier. Even though in this case, it may not actually be required in this particular order, because the model data class will only going to be accessed when we call the load panels method. So as you can see, what's going to happen here when we call load panels, and again, that method is going to get called when a model finishes loading into the viewer, right? What we're going to do is we're going to compute data from our model. We're going to find all the different occurrences of the property values. And when that is ready, we're going to empty the dashboard div element. And for each panel that was passed to us in the constructor of our dashboard, we're going to create a new panel in the dashboard div. So that's for the layout adjustment. All right. Let's also add a couple more styles, because we added some custom classes and the new HTML IDs with our jQuery code. So we'll want to make sure that these additional styles are also covered somewhere in our CSS. So let me just copy this one, and I'm going to add the CSS styling to my main CSS file. Again, it's better practice to maybe split the CSS files depending on what they're related to, right? So you could have one CSS file for your dashboard styling, and you could have another CSS file for styling your application itself, or just maybe the sidebar or the toolbar maybe. Okay, so these are, again, we're basically just saying that the dashboard panel, that's the new div that we're going to place all the way to the right, that we're going to squeeze next to the viewer, right? We're basically saying that the height of that div should be 100% of the viewport height, so all the available height of the browser window, minus 100 pixels. So that's, again, keeping some space at the top for the toolbar, right, for the navigation bar at the top. And the transition width class that we're using here, this is basically a little nifty eye candy with which we basically animate any changes to the width of that element to be animated over 1 second with this ease in and out smoothing, right? So that's just a little, so the charts don't just pop up out of nowhere, but they're actually slowly move in over 1 second. Okay, that is for our styling. And it's actually everything ready for, everything that's required for us preparing the layout and the real estate for our dashboard. So again, if you're using your own app, just make sure that you update this adjust layout method to make sure that there's actually a div element somewhere in your HTML layout called with the ID dashboard, and that it has some reasonable size, because we're going to start adding charts to it very soon. Okay, and I believe we can move on to the actual charts. So first of all, what we'll need to do, as I mentioned at the beginning of this webinar, we're going to be using this open source library or open library called charts.js. And so in order to be able to use that, we're going to need to actually bring in some JavaScript code and CSS for the library itself. That is done through these two tags, the script link tags. So let me copy those and bring them into our index HTML somewhere towards the top. We're going to add them here. Okay. And second, we're going to create a new file under our dashboard folder in our source code. And we're going to use that to build basically a subclass of a dashboard panel chart, which is something we built earlier during the previous session. So we're going to take that generic class that was meant to be a panel of a dashboard that includes a chart. We're going to copy that into clipboard, and we're going to create a panel bar chart JavaScript file in our dashboard folder. Panel bar chart JS. All right, panel bar chart. I believe that was the right name under the dashboard folder. All right. What's happening here is, again, we are going to call the load method of our parent class, that's the dashboard panel chart, to initialize the real estate for the chart itself. And then we're going to call draw chart, which is where we actually create a new instance of this chart object from this chart.js library, right? So this is something that you will find documented in the chart.js documentation. This is one way to initialize the chart. You're going to get a context, rendering context of a canvas. And the canvas is actually something that's going to get instantiated for us as part of the parent class initialization, right? So that will create an HTML canvas somewhere in the dashboard area. And this way, we'll basically get a rendering context that the chart library will then use to render into. Right, and we're going to say, okay, we want a bar chart, and now this is the interesting piece where, you know, when configuring the data that should appear on the axes and the values for the bars themselves, we're actually now finally using the model data helper class. That's the class that, again, computes the occurrences of all the different values for different properties, right? So we're using the methods there, like get labels. We can review that one more time. Yes, get labels, right? So when we store this data structure in memory, again, as I mentioned earlier, it's an object where every key in that object is a property name that exists somewhere in the model. And each key then includes an object, again, with keys representing the different property values, right? So this is what we're doing here. We're basically saying, okay, take all the values I see for a specific property name and return all their keys, right? So that's basically, so if we have a material property and that contains values such as concrete, glass, wood, this get labels method will include an array of these values, right? Like wood, concrete, glass, metal. And we're using that here to basically use these values, concrete, glass, as the labels for the different bars, right? Because what we'll want to be able to do in the bar chart is showing the number of occurrences of these different values of the, let's say in this case, material property. And how do we know which one, which property? That's actually something we pass into the constructor, right? If you remember, when we were creating the dashboard, we created a pie chart and a bar chart, and we passed in some string called material. So this way, we're basically telling the bar chart, okay, I want you to show me all the occurrences of the different values of the material property, right? So if there were like 5 objects with material set to concrete and 10 objects with material set to glass, I want to see 2 bars, one that's 5 units tall and one is 10 units tall. All right, and then for the actual data set, this is where we count the instances. So if you remember correctly, that in that data structure we're building in the memory, we are keeping a complete list of object IDs that actually have that property set to that value, right? But in this case, to get some data for the bar chart, we just need the number, right? Just number of objects. So we are using this get count instances helper function, which just gets the length of the array. All right, and setting some UI styling for our chart, and that is it. Oh, and one nifty little feature here, you may see that we're also defining an on-click event handler on the chart. What that means is when the user clicks on one of the bars of the bar chart, we want to react in some way. And what we're going to do is we're once again going to use the viewer APIs to isolate all the objects representing that specific bar in the bar chart. So if I click on, let's say, the concrete bar in the bar chart, I want to highlight all the objects with material properties set to concrete in the 3D view. And that's exactly what we're going to do here, right? So we're basically saying, okay, based on the property that we're showing the chart for, by default, it's going to be material, right? I want to get the specific value. So let's say in this case, concrete. And I want to get all the IDs of all the objects that have material properties set to concrete. Right? And we can just isolate these using the standard viewer APIs. Okay, that's for the panel bar chart. And now we can also get the pie chart. It's going to be very similar. We can just copy the snippet into clipboard and create a new file called, this time, panel pie chart under our dashboard folder. Panel pie chart. And again, very similar, right? It's just going to call its parents classes load method to initialize the HTML area with the HTML canvas into which the chart can be rendered. And we get the rendering context for that. And this time we're just creating a donut chart, right? And in a similar way, we're calling this helper get labels method to get all the labels, text labels that should appear, that should be used for the donut chart. And again, we're counting the instances to show, what portion of the entirety of objects have the material property set to concrete, let's say. And again, even here, we're once more adding this click event handler so that when somebody clicks on one segment of the donut chart, right, we want to react to that. And we react to that in the same way as earlier, just basically isolating all the objects in the 3D scene, all the objects that have the material property set to that specific value. All right. Now, again, we must not forget to bring our JavaScript files into the HTML. So let me go back to my HTML and add a script, JS dashboard panel bar chart, up too many slashes, and one more for panel pie chart. Again, the order should not be as important here because when you, for example, when you look at the dashboard.js file, this file does depend on bar and pie chart and the others like the model data, but these are only loaded later when the document is ready. But still, it's a good practice to keep them in the order in which they depend on each other, right? So we know that the panel bar chart and panel pie chart definitely depend on dashboard panel file because that's where their parent class is defined. So this order must be maintained, right? And then it's what I do here. I just add dashboard at the end because dashboard is the overall UI class that actually depends on all the previous ones, right? Because the dashboard itself then uses the model data helper structure as well as the specific bar chart and pie chart. Right. And that's pretty much it. Now let's see. So for now, let's keep the material as our property that we want to generate the stats for. And later on, we can play with that. All right. Let's head back to localhost 3000 and open our model. All right. So see, now it actually waited until the toolbar was added. And as soon as the toolbar was added, that little trick we used with the DOM node inserted here, right? So at that point, when the toolbar was added, that's when this code was triggered. And we checked, oh, is the viewer available? Yes. So as soon as the toolbar appears, we squeeze the sidebar and the viewer to the left and make some area for these two charts on the right. And that's exactly what it's supposed to be doing, right? You can see that since we're using material, the charts basically ask our helper model data structure class for all the values that appear for this material property on all the leaf objects, right? And it found that all the values used throughout this design for the material property are metal, glass, brass, iron, cast, or aluminum, right? And it's indicating the value by basically the number of occurrences. So we know that, again, there were 44 objects with their material property set to glass. And now the cooler part, since we've specified the click event handler, if we click on the bar, we can control the viewer state back, right? And what we do here is basically call the isolate on all these objects. So we're basically saying, keep everything with material set to glass visible, and everything else make it transparent or semi-transparent, ghosted. I can show everything, and you can try maybe the metal. So now you see that there are 144 objects with the material property set to metal paint finish dark gray matte. Right? We can see these as well. We can click on a grass. So now we're seeing everything with material set to grass, or everything made of iron. And that's it, right? We now have our fancy app that can, again, process the metadata of our designs, turn it into, compute any kind of stats that we need out of it, and visualize it in any way we want. In this case, using a bar chart and a pie chart, right? The same goes for, this is showing the same thing, right? You can view all the glass material objects or metal or iron by clicking on the different donut segments as well. And that is it for our demo and for our webinar today. Okay, so before we give you time for your turn to wrap this up and finish your dashboard creation, let's see if there are any questions or comments. All right, question. Can we input values to our charts that are coming from different properties? For example, material and structural material. I'm not sure if how you would visualize these at the same time. So I'm not sure if you're actually asking about computing these aggregated values for properties with slightly different names. That could probably be done. You would just need to update that logic that is processing the properties, right? So maybe instead of, if we come here, maybe instead of specifying just a single property, maybe you could update your charts to accept an array of properties. So we could say, look for everything that's either material or maybe structural material, right? And then, but then of course that you need to dig deeper and update the data collection logic that would be inside the model data class here, because here you would not be looking for a single specific property, but for multiple properties. So it can be done. It would just need some overhaul of the logic, right? But again, you control everything here, right? This is your code that is building this histogram of the occurrences of different property values. So if you wanted to modify it so that it actually counts the material property and structural material property as the same thing, as one property, you could, right? I'm actually thinking we could just hack it slightly. I mean, again, it's kind of a hack, right? But what you could do, it's actually right here, because we already have some adjustment here, right? So what we could do is we could say, if the property display value starts with, or if it equals, maybe that's safer, structural material. Need to learn the type. We can say, well, if the name of the property is structural material, for these purposes, I'm just going to rename it to material, right? That's pretty much it. It's kind of hacky. Again, I wouldn't recommend going that way, but it's showing you that you have full control over how you compute your data that is then used to feed the charts, right? So here what I'm saying is, if the name of the property that I'm just currently processing is structural material, I'm just going to reset it to material. So it's going to count towards all the other values of the material property. We could give that a try, maybe see if we get any better results. I'm not sure if there are any properties in my model called structural material. Let's give it a try. Right, let's see. No, there's still a difference. Probably not. No. So in my case, it looks like I don't have any objects with a structural material property. But anyway, this is just one way you can hack your solution. So again, you can generate the data in any way you want. All right, one more question. In order to make tabular data, would you use the same library or perhaps another? So for tabular data, typically when I'm working on different samples, I'm not using third-party libraries for that. I typically just do the tables myself in a very simple way. But I think I remember I was looking at some jQuery table plugin in the past. I don't remember what it was called. I was just checking it out if that would be data tables. That was the one. Yes, data tables. So I was reviewing this jQuery plugin in the past. I was thinking about maybe using it for one of my samples, because this one supposedly it's supposed to give you like different sorting, reordering of columns, searching, pagination with custom page sizes, stuff like that. But I think in the end, I ended up just doing my own simple tables. But I guess that's up to you, right? To your preference. I think BIM 360 issue editor was one of my samples that I was considering for that. But ultimately, this is what I did. I ended up just building an HTML table, and I made it look it looks like this. So it's maybe you cannot reorder columns, but you can still filter by something, and you can go through pages, and that was pretty easy to do with standard jQuery and Bootstrap. So there are options for jQuery depending on how fancy you want to get. But personally, I'm just whenever I needed to build some kind of a table like this one, I just used an HTML jQuery and Bootstrap. All right, one more question or comment. The app works fine. The dashboard is a little limited when using richer models due to the large room required for the legend. That is true. In the morning, you showed us get properties and share what you use for unsuccess callback. Get properties. This is when we were computing the data for the charts, right? So let's take a look at that. Please type this. I will be away from the group. Okay, well, I'm just going to explain it for everyone here. And again, this session is recorded, so Edgar, you'll be able to, if you can't catch it here, you'll be able to get that information from the recording, hopefully. So how did we again build the data that we use to populate these charts? we can actually, you know what, let's do that in the code. I think that's going to be the best way for you to get a grasp on what's going on there. So remember, we have our model data helper class, right? Model data. This is where we collect all the leaf nodes from our model, all their IDs, right? And then we request their properties, and we use those properties to start building this. Data structure of which properties have which values how many times. And that is all happening inside this init method of the model data class that we added earlier. So let's put some breakpoints there. First of all, I'm going to put a breakpoint here and right at the beginning of the callback to the get all leaf components. This is where we're going to check which IDs we've received from the get all leaf components method, right? And then we're going to put a breakpoint maybe inside here when we retrieve properties of every one of the IDs of these leaf objects, right? We're going to, and then for each property, I'm going to step inside here and see what's happening there. All right, maybe, hopefully this will be visible, nicely visible. All right, so let me reload the page now with our breakpoints in place, and let's see what happens. All right, so see, now we're initializing our dashboard. So we're creating a new instance of our model data helper class, and somebody now called this init method asking us to prepare to compute all the data for the charts, right? So what we do here, we call to get all these components, and in the callback, we've received this list of 439 objects, again, that contain some value for the material property, right? That's good. Now we're gonna, for each of the IDs, we're gonna ask for its properties. We have a breakpoint there on line 52. Now we've received properties, so we know that for object with the ID 2040, there are 48 properties because we requested all of them, right? And what we're gonna do for each property, so now we're looking at a property called category, which has the value Revit floors. We're going to step through and we're going to say, okay, so if the display value starts with the angle bracket, we're going to change it in a certain way, right? Or skip the processing. Here, this is the extra hat I've added, right? So if the name of the property is structure or material, I would replace it with just material. But that's not the case. But now this is the important part. This _model data is that object in memory that we are now populating with the different property names and property values. So what we check is if the model data object does not contain a key called category, we're going to create one. And we're going to set it to an empty object, right? So now the model data object is empty, but as soon as we step over this line, now you see that our object now has a first key at the top level, and that's the name of our property category. And that object is empty for now, right? Now we check the actual value. We're asking, okay, so for this particular category, the object for this category, does it contain the key called floors? And if not, we're going to initialize it. We're going to add the key and set it to an empty array. So let's step over that. Now, if I hover that, you can see that now category, my top level key category contains an object, which has a key called floors, which is empty for now, right? So this is where we're going to start storing all the IDs of all the objects that have the category property set to floors. And here we're basically, this is where we're just pushing the ID of our object to the end of that array. Now we can move on to the next property. So this time we're looking at let me put it here. Now we're looking at a property display name, property called level, right? Which in this case, for this particular object, is set to level 1. So we go through the same process here. We take our model data memory object, we check, does it contain a key called level? And if not, we're going to create the new key and set it to an empty JavaScript object. All right, so now we have two properties, category and level, right, for different names of properties. And now we're asking, does this level object contain a field called, a key called level 1? And if not, we're going to add it. So see, now we have top level key called level that represents the name of a property. And inside there, we have already a first key, level 1, that represents one of the possible values. And it's an empty array for now, right? And now we're basically pushing the DBID there. And this would go on and on and on and on. And let me put one more breakpoint here. Actually, yeah, let's try that. Edit. We can say stop here if count equals 1. Find 1. All right. So now we should be ready, and you can see that, wow, okay, so now our in-memory data structure with all the computed data results, right, now contains many different keys, the top level object. And again, those are all the different property names that exist in the metadata of my model. And if I, for example, expand base material, you see that, okay, well, for base material, there is only a single value that is set to the property, and that is Herman Miller veneer 1. And that one is used on two objects with IDs 5587 and 5287 and 5288. Maybe let me try if I can see some other base level, right? So we now see that there are a couple of objects that have base level properties set to ceiling or set to level 1, or set to level 1 living room, or level 2. So this is how we build this kind of strange in-memory structure, right? That we then feed into the charts to show the stats for different properties. All right. And trying to see, there was one more question. All right, one last question. Can we create a drop-down menu? Yes, with the names of our properties in order to select them from the UI. Okay, yeah, I promise that if there was some time and no other questions, that we could take a look at that, and we can definitely do that now, unless there are any other questions. So let's say we want to take this step a step further, right? Maybe we want to add some selection drop down somewhere in here, maybe, or it doesn't matter. We can maybe put a drop down here, right? That will show the different properties used by used in our model, and that will allow us to maybe toggle to switch to a different property, right, that we want to show. So let's see how we could go about that. All right, so now it's hacking time. So no promises here. Let me stop the app. So first of all, what I'm going to do is, when we're creating our dashboard, right, what we do here, we're adjusting the layout, we're creating new dashboards. Here, when loading panels, here what I would do is, I'm going to say, before we load our panels, we're going to add a new HTML element called select, and we're going to name it property name. And inside that property name selection select element, we're going to be using that we're going to populate that with all the different properties that might be at some point available in our model, right? So let's try this. So it's going to be at the top of the dashboard, and below that, we're going to start loading the dashboards. That should be fine. And now, for now, I'm just going to try something. So I'm going to say name of material base level, maybe, or level. we're going to populate this property name select element with some additional, with option elements, right? So here I'm basically using jQuery to build some piece of HTML programmatically, right? To select with some options in it that's going to create a drop down. So I'm going to say the value is going to be the same as the actual text of each option. All right, so let's see what happens there. Open a model. Okay, so you see now we now have a fancy new piece of UI here, a drop down. For now, with just these three hard-coded material, the property names, right? So next thing, let's see if we can populate this with the actual property names found in my specific model. For that, we can actually go back to the model data helper class, right? Because here, this should already give us well, actually, maybe this will not be able to, we won't be able to find the properties automatically, but we can still get those. Let me show you how. So we know that our this weird complex in-memory structure contains these, this object with top-level keys representing property names, right? So what we can do is we can simply get, let's say, get all property names. I'm going to add another helper method here, right? And what we're going to do is we're going to say return object keys, which is a built-in method on the object class of this model data. So that basically means give me an array of all the strings that are used in this object as keys. And we know by now that these will be the different properties, right? So get all property names is what I decided to name my function. So I'm going to go back to here, and now instead of using some hard-coded list of strings, I'm going to say data dot get all property names, right? So this should theoretically populate our selection of the dropdown with all the different properties that were discovered in our model by this model data helper class. So let's try that. All right. Whew, there we go. All right, so there's quite a few properties, right? That's good. Now what we need to do is we need to react to that event when we change the property to something else, right? We want to make sure that these charts actually are updated as well. So now that piece might be a bit trickier because I'm not sure if the way the charts are implemented right now, if they allow for easy, updates for different properties. So let me see what would be the best way to do that. Maybe, we can do it, no, maybe not like this. Okay, it's going to be kind of hacky, but let's see if we can get that working. I'm going to use jQuery here one more time. I'm going to use this construct, which basically says whenever the value of this element, which is our dropdown, whenever it changes, do something, right? And here, maybe again, it's going to be kind of hacky, but it might work. Let me try something. We're going to try and basically just delete. What I would try would be to just delete these divs. So it's called dashboard panel. So anything that has the class dashboard panel, I would just remove. And we can do that like so. Anything that has dashboard panel, we can just call remove. So basically, yeah, what we're doing here, we're saying as soon as somebody changes the selection from that dropdown, we want to clean up any existing charts, and we can maybe recreate them one more time, but with a different property name. Now this is, okay, let's see. So we would have to change the property to use. So again, this is kind of hacky because these charts are not really implemented in a way that would allow us to easily update the property, but we can, with a little bit of kung fu, we can get there, I think. So what we're going to do is for each panel in the list, we're going to call panel property to use equals. Now we're going to change it from the original one, which was material, to something else, right? And that's going to be the value to which the selection is actually changed. Now that is done in jQuery like so. So we're going to say, take this dropdown and find the currently selected value, and we're going to add it to the panel. We're basically, we're going to override the original material property with the newly selected property. And then we're going to load the panel one more time. So let's see if that will work. We'll put a debugger inside the change event listener. And try that one more time. Oop. All right, we've got our charts. And now what if I select, oh, there is actually structural material. So did I make a typo? Why didn't I see anything over here? Let's try this. So I'm going to make a change in the dropdown. Boom, we've hit our debugger. So now, when we run this jQuery line, this should remove all the charts or any HTML elements that have the dashboard panel class. All right, our dashboards, our charts are gone. And now, again, for each panel, we're going to this time override the property to use, because see, now it's still set to material, right? But we're going to change it to something else. And we're going to change it to structural material because that's what we selected in the dropdown. And we're going to basically ask the chart to be loaded again. So let's see if that works. Ooh, okay, that works. Although, where did our donut go? Ah, there it is. Whew. It's going to work. All right, so let's try that some more. How about level? Right here at the top. Boom, look at that. Level 1, level 2, and foundation for ceiling. Nice. All right, so that works. Here's your customized dashboard app with dynamic property selection. Let's try some more. Let's see. I'm not really a Revit person. I'm not that familiar with the type of data that Revit defines. So I'm not sure what would be a good property that has different values. Maybe base material? Nope. Not great. Enclosure? Maybe? Nope. All right. Maybe some other. Panel name? No. As you can see, so again, it's kind of hard to find the good property for these type of demos. Here I'm just guessing. Type. There you go. Rectangular or none. That's not very helpful either. All right, maybe some other. Frame material. Right. Aluminum or solar world silver metal. There you go. So what do you think? you guys want to share that code? Okay, well, it's kind of messy. I'm not sure if that's something I want to share. It's not something I'm particularly proud about, but all right, okay, yeah, I'll generate a gist and I'll share it with you all. All right, so let me share it. I'm just gonna go to GitHub. to learn to type. Oh. Does anybody else have problems with the keyboard, the butterfly keyboards on MacBooks? I find it's getting worse in my case. Just some keys don't register at all. Some keys register multiple times. Some key presses. It's kind of annoying. All right. So let me create a new disk. All right. So would it be enough to just share that one file here? Or did we change anything else? No, I think it's this one, right? Just the dashboard.js. We didn't have to change anything else. What we did, yeah, here we programmatically add the dropdown. We populate it with the different property names that were discovered. And here we're just reacting to a change in that selection dropdown. So that's pretty much it. So, okay, I'm just going to take this whole dashboard.js file and share it with you. And again, this is going to be the important piece that adds the dropdown. All right, create public. Yes. All right, coming to you. Cool. Okay. Any other questions? Something that isn't clear, or some feedback maybe? Nope. Okay, in that case, let's go back to our slides. And all right, what's left for us? No questions? Okay, so then in that case, there is one more day to go in our Forge Online training event. Tomorrow, my colleagues will take you through the Forge Design Automation Service and show you how you can use it to process your Revit or AutoCAD or Inventor models remotely with your custom plugins, Revit plugin or Inventor plugin or AutoCAD scripts, all of that through Forge. So I hope that's a very interesting topic. I definitely recommend that you check that out. And I hope you'll like it. And as for support, one more time, we use these two main support channels. First of all, if you have any question that is more proprietary, maybe more specific to your product, maybe you need to share a snippet of your code or some testing design file that you don't feel comfortable sharing publicly, just send us an email to forge.help@autodesk.com. This is an official email that we're monitoring, and we get a notification every time there's a new message coming in, so that me or Deepali or one of our colleagues, whoever is available at that moment, can help you out, right? That's for those when you want more like private discussion. If you have some general technical questions about the platform and one of its components, definitely we encourage you to head over to Stack Overflow, because first of all, you may already find an answer to your question there. Second, it's also nice that when you ask your question there and we answer there as well, you may help people in the future who may be asking the same thing, right? Another good, another advantage is if you ask your question there, you may get feedback from the community itself as well. So that's quite nice. So we definitely recommend, again, if it's some, general, publicly shareable question about Forge, definitely go to Stack Overflow and ask us there. We're going to get the same notification in our system from Stack Overflow. So we will, again, have someone on our team who is available, go there and answer or help you with your question there. All right. And that is all for me today. So Deepali, thank you one more time. I know it's crazy late for you. So thank you for staying this long with us, and helping me out.
Thank you, Petr.
I really appreciate
it. It was very interesting.
Yeah, thank you so much. So go get some rest. It's been a wild week. I will stay here again for about half an hour because again, this is our last session for today. So if you run into any problems, if you have any last minute questions, drop me a note in the chat or in the Q&A and I'll get to it. I see there's one more question. No, just thank you. All right, thank you guys. This has been incredibly fun. I hope you all enjoyed it as much as I did. So this is all for me this week. Tomorrow, again, it'll be my colleagues guiding you through the design automation tutorials for Node.js and .NET. So I'm just gonna relax for a little bit, gather my strength back, and I'm really looking forward to hearing back from, because one thing we want to do, well, first of all, we will share the recordings of all these events with you. Now, I've been thinking about the timing. So I think, tomorrow, Friday, we will need to wait for our colleagues in the US to finish their tracks and their recordings as well. And then I think I'm also going to need some time to process the recordings, right? I'll need to go through everything, cut out, empty spots or, noises, stuff like that. So it'll take me some time to prepare to cut the recordings. So I think that, I won't be able to get those to you immediately tomorrow. I think it's probably going to be early next week. So please be patient with me. But we will definitely share the recordings with all of you, everyone who registered for this event, even if they were not able to attend. And also, we will be sending out a survey. And I would really, really appreciate if you could spend a couple of minutes of your time to give us feedback, because this is the first time that I've been trying to organize this event to help my colleagues. And I really want to make sure that, the event is as good as possible for you, that you can, that you find it as helpful as possible. And for that, we really need your feedback. We need to know, what worked, what didn't work, right? What could be improved. So if it's something in the event organization itself, if it's something in the sample code, if it's something, in the presentation, or, anything you can think of, if you can give us any feedback, I'd be extremely grateful, because then I can make sure that next time we do this type of event, we can make it even better. So please stay tuned. You're gonna get an email with a survey, and again, if you can spend a couple minutes of your time, I'd really appreciate it. Will we get any kind of a certificate? That's an interesting question. I like that. That's a first really interesting piece of feedback. We haven't been giving out any certificates for these online trainings, but we might. But this is something I think I'm going to have to discuss with our marketing and legal. So let me write that down. That's an interesting request. I like that. No, I mean, it's good, right? I mean, why not ask? Kind of certificates. I could maybe draw something for you for now, but I'm not sure if that would be very useful. But I will definitely bring that up with our team, if we could maybe consider some kind of a certificate for you guys attending these online training events. Well, thank you for the question. It's a great idea. All right. Yeah, thank you, Deepali. Again, thank you so much for helping me out with answering the questions while I was demoing. Otherwise, I think it would have taken significantly longer.
Okay, thank you. Bye.
Bye, Deepali. All right, so let me stop the recording. Boom.